Good morning. My name is Justin. I'm from the United States, and I've been a professional programmer for a little over 8 years, and for the past 3 years I have been working as a full-time Unreal Engine developer. Primarily my work is in C++ programming, but working with a lot of different independent studios and on personal projects, my work has had me touch on every single part of Unreal Engine. One of the largest games that I was a part of was Fishing Barents Sea, and I was lead programmer on that project. You can find that on Steam. So let's talk about what we're going to do here in this project. We are going to build a roguelike game using Unreal Engine blueprints. This is going to be a blueprint only game, and blueprints in Unreal Engine is a visual scripting language, and it's very powerful compared to other visual scripting languages. And while Unreal Engine originally was not intended to be used to create games with only the blueprints, it is possible, and they have been adding features and content for blueprints for quite a long time. So the best way to learn how to build games, how to build a roguelike game, and how to work in blueprints in Unreal Engine is by doing that actual thing. So that's what we're going to do. We're going to build a roguelike game. So here we have the project page, and the way we're going to do this project is you're not going to be required to be a professional programmer. And in fact, I'm actually going to try and do this so someone with absolutely no experience in Unreal Engine or software development can come in and follow along each step of the process and still create this game. Now, and when we're done, then they can expand upon it and change graphical assets and add their own story to actually develop it into their own game. So let's take a look at the curriculum now. We're going to be using the project from the part 1 of creating a roguelike. So it might be more useful to have taken that course, or to have the project files of the completed project, which are available with this course. You can also follow along with what we're going to be doing, although it may be a little harder. Some of these systems can be taken out of the context of the project and used other places. So the first thing we're going to be looking at is creating an event system for ECS, and that'll be doing things with taking turns, and we'll have task times and the event queue, and we're going to see how that works. And then we're going to be looking at creating enemies and AI and do some very basic pathfinding to follow the player. Then we'll be creating a combat system and have the AI attack the player, and then we will have player levels and upgrades and things like that for the player. So I hope you will join me in creating a roguelike game in Unreal Engine. Have fun! Good morning and welcome back to making a roguelike game in Unreal Engine. So last time we didn't get a ton done, but we got the map set up a little bit better. So this time we're going to try and move ahead as quickly as we can. The first thing we want to do is create an event system. So basically things happen in a turn order. So what we're going to have happen here is, this is our event manager, and basically when someone wants to do something, it's going to go through, it's going to say, is this a valid option? If it's valid, the system is going to queue up that event, and once that event is reached, it will be executed. And then, so whenever the player's event is executed, the game will stop and wait for more player input, and then it'll execute everything until the player's event is then executed after that. So let's get started and set this up. Alright, and the first thing we want to do is we want to, in the player control system, we want to validate the player input. So what we're going to do here is we have the player entity, and it's assigning itself to the map manager. Also, whenever an entity is created, we want to make sure they also register themselves with the entity manager system. So if we look at the entity class, oh, this already has it does have component implemented in here. Haha, I forgot that I was using custom things last time, but we have that set up. So on begin play, we're adding all our components. We also want to get all actors of class, and we want to get our entity manager, and there's only going to be one of those. So let's go back here and look at our entity manager, and we're going to add a variable here. And this variable is going to be our list of entities. So we're going to make it type entity, object reference, and an array. Now, we could have every entity register itself, or we could only create entities inside the entity manager, which I think is what we'll do. So let's go back to this here, and we're going to scrap that. So right now only the player is being created at the game start, and the player can add itself to this array. And I think we can pass a reference as well for the entity manager, so all entities know what the entity manager is. So let's go here and say, actually, now when they die, we'll have the entity manager remove them as well. We'll leave the entity management in the entity manager. Let's keep saying that word, entities. Anyway, so the player, we're going to go look at the player control system, and the player does input in a, let's close out some of these other things real quick, and we want the components, so player control. So player does input, says, hey, this is what I want to do, and when should have a call to the parent component. Sorry, I'm just looking to make sure all this stuff exists here. Yes, but there's nothing in there. It's just meant to be registered. So yeah, let's leave this empty. So the player here is the player control system, and we want the player control component. So it's going to say, hey, we're going to go in here. I want to move input, has movement. So the player system is going to check out and say, hey, I've got a player input. So let me see what I can do with that. It's going to go in and say, here I have our movement cast entity. We have the movement component. It's valid. Do the movement. Now, before we do that, we want to actually check and make sure that this is a valid movement request. So we're going to, here we have the player controller object reference. So we're going to get attach parent, and that's going to be our entity. And we're going to cast to the player. And we are going to get component, or forget what the, let's look at the entity real quick. What's it called? It does have component. There it goes, and it returns it. So the player control again. The system does have component. And we're going to look at position. So if this is true, we're going to do this first. And we're going to call that execute move, but we don't want to do that just yet because we're going to have to integrate it with the event system. So, what is this warning? Player does not inherit from scene component. Oh no, we want to get attach current actor. That's what we want. And we want this from, here we go. All right, I used the wrong node there and it auto converted. There we go. So we have a position component. Now we're going to be looking at, we have the movement and the requested move input here. So we're going to get the position. Let's say get location. Oh, we need to cast this because it's a generic component class actor reference. So we're going to get position, and this is going to say where are we? What was it called? Location. Let's check out components. Position component has a position. That is an int vector. All right. We go back here to the system. So as a position component, okay, position. I don't know why it wasn't showing up before. Anyway, let's create a macro we can do in our actors. So we're going to do some more macros here. So it's the blueprint class and let's right click, blueprints, and macro library with a parent and actor. And we're going to just call it actor macros. And let's make a new one, and we're going to call this add int vectors. Oops, I don't want to add that new one yet, but let's just do this, and this is going to have an input, two inputs, v1 and v2, and they're both going to be of the type int vector. And we're going to have an output of the type int vector, which is v3. So let's split this and split this, and we're going to add the integers all together, x, y, z. Then we're going to make an int vector from the resulting values. And there we go. So now we can set that up. So add int vector. Let's call add int vector. We say add int vector. There it is. So now we're going to do, this is the control system. So the control system is going to need to be able to see the entity manager. And so the way we're going to do that is we want these systems, whenever a system is created, we want it to be able to see the entity manager. So every system will be able to see the entity manager. So the system manager is going to spawn the list of systems. So right now we have the movement, the player controller, and that's it. Yep, we only have those two systems. So an ECS system is going to have a variable of entity manager, and that's just going to be a pointer to our entity manager. It's going to be of type entity manager, and we're going to expose on spawn instance editable. So whenever the system manager creates a class, actor class reference. So we can make this actually a Since these are only going to be systems, ECS system class reference. Spawn actor from class. There we go. We only have to worry about that being systems and the event graph. We can look here and we can just drag this in here. Systems list is going to be an array of actors, but we can make an array of movement and player control systems. So let's call it ECS systems class references, change variable type. You don't need to worry about that right now. So we'll do a for each, because this loop is still looking at actors, and now this loop will output system references. There we go. So we can compile, and our spawn transform will just be at 0, 0, 0. And the ECS system manager, which is one of the few things that are in our level when we start, is going to look for our entity manager and give it to all the systems. Let's do that on begin play, and we're going to say get all actors of class, and I'm going to say entity manager because this is going to be something that exists in the game. We can promote this to a variable, and we'll just call it EM. Now we can go back to our spawn systems, and we can get our EM and drag it into the entity manager. So now every system will have a reference to the entity manager, which is great. So we go back to our player control system right here, and we're going to go and get our entity manager and get entities, and we're going to do a for each loop, and I go does have component, and if this is valid, the component we're going to be looking for is a collision component. If it does have a collision component, we're going to cast this to collision component and does collide. Why did that jump off? Oh, that's the player. Collision component. Oh, I took off the context sensitive. There we go. Get does collide. Excellent. All right. I used the same value in the player, and I was looking at that. So we're going back here to our system, and it's valid. It's a collision component. If it's colliding, branch yes true. And we can, set this up in entities and say, is colliding, and it'll check if it has a collision component and the Boolean. So those are, things we can streamline down to make work in the future easier. But right now, we'll just finish this up to make sure the player has a valid move. And if the move is validated, we'll add to the event queue. So this entity does have collision, but first let's do this. We're going to say it does have component and say position. And if it's valid, we're going to cast to position component. There we go. So do we have a position component? Is it valid? Cast a position component. Get the position. And is it going to be equal to where we're moving to? We don't have that right now. So let's go back to our macros we were making. And we'll do another int vector macro. So int is equal int vector. So we can have inputs here. It's going to be an int vector. Oh, what happened there? All right. v1, v2, and the output is just going to be a bool. B is equal. So again, we can split the pin structs and do an equality equal integers. So we're going to have 3. So x, y, z, x, y, z, and we can combine these into an end to make sure that all 3 of them are true. So if all 3 of them are true, it is in that those vectors will be equal. So let's go back to our player system and say equal or is equal int vector. We're going to do here, and we want to branch. So if this is true, then we are going to go up and check if they have collision, and if they do have collision, it's true. We are going to invalidate this move and not do anything with it. It's basically going to say, let's make a print string here to tell you this move is not valid. You will collide. And we can add that to the UI or something later, but for right now, I'll just have a screen message letting us know this, and it's working. Where is this here? The array element is an entity object reference. Oh, we don't want to cast the array element, we want to cast this component. Had a wrong hookup there. So now let's say it's false. So let's say that we're going through all the entities. And so if this is true, let's create a variable move request is valid. And we're going to set this to false. So before we do this, we can set it to true, and then it checks, and if it doesn't work out, we're going to set it to false. There we go. So all this is done here. Once the loop is completed, we're going to come down here and go on a branch, and if the move request is valid, we will do all of this stuff where it's going to say, hey, let's move the things here. So this isn't going to do anything right now. You know, we're just moving around still. There's nothing to collide into, there's nothing to test there. So let's make another entity. Let's call it a monster. Oops. And in our class defaults, we're going to give it a collision component. We are going to give it a position component. We're going to give it a static mesh component. So let's see, in our player, what do you have? We can give it a health, and we haven't created an AI component yet, but we will give you health and movement. You will be moving. And when we create the AI component, we will add this in here. All right, so let's wake this up. And that'll create it. And then just like in the player component, we can have some defaults, such as a player mesh. So we'll have variables, monster mesh, and the default of that is going to be a static mesh. So I type out static mesh object reference. So for our player, we are using the starter content. Let's go look real quick. Shape narrow capsule. We can use a shape quad pyramid because that looks neat. So let's just grab that name and we're going to do a shape quad pyramid. Now let's go look at that and see where its pivot is at. There at the bottom, so yes, it will basically stand on top of the what's it called? Stand on top of the tiles. Now let's make a new folder here, and we're going to call, entity assets. So let's just right click, make a material monster met, and we're going to do hold down 3, left click again, and we're going to make a nice red color. Put one in the red and bring it down, make it a little darker. Out there, that's good. So we can apply, see a nice preview on our little triangle here, or on our sphere. Save it. And our monster on begin play is going to, oh, well, we can actually set this here. Let's bring both of these to entity assets, copy here. And this is going to be the player shape. And this is going to be our monster shape. So we can go tell the player to use player shape as opposed to the capsule. So anything we do to this will transfer there. The monster shape can use a default of monster matte to be nice and red, dark and scary looking. So when the monster spawns himself, he will look like that. So let's just throw this out here, and we're going to do a, where are we? Our entity system, entity manager. So in our begin play here, since we're spawning on begin play, let's just also spawn another actor. We're just going to put a sequence node in here for right now. And spawn actor from class. We can put it behind this branch here to make sure we're not coming out of paused. Because eventually we're going to put all our logic here to determine if we're starting a new game or coming from a what's it called? Coming from a save game or something like that. So we can have these little spawns here. So we spawn an actor, we're going to spawn a monster. And let's split the pin struct. And what we're going to do is add them as well. And the transform can just be, let's put it to the right. The position component could have should have a set position, or the position component should have a position system where we can set position, which will give it the XY coordinates like 1, 2, 3, and we'll set its location properly. But what we're going to do right now is just, let's say we're going to set it 500x and 500y, and we're going to does have component position, and we're going to cast this to position, and we're going to set position. We can split the pin struct. So this is we're just kind of faking it right now. So it's going to be at 5, 5, and we'll know that. And the monster also B does collide is also going to set its collision boolean as well on load. So you can have monsters that don't collide if you want, you know, ghosty things that can only be shot by magic or whatever. But this guy's going to collide. It'll block the player, you know, can run into you, things like that. So just like in the player in the beginning, we're going to get its components and loop through, and we're going to set up that too. We can do its starting health. So what do we have here? With our player controller, that's setting up the camera. All right, and variable. Oh, let's actually, we pasted this in here. It doesn't exist, but you can right-click, create starting health variable, and compile. So we'll say that's 100, and we'll get this. And we don't want the player mesh, we want the monster mesh. Do the monster mesh. There we go, no more errors, all happy. So let's see what happens right here real quick. We'll go to start, and did we spawn a monster? Oh, there he is. It's kind of far away though. We can move on to him. Oh, there you go. So he's right there, but where I put him is it's a bit out of, it's not in the right place. So we go to the entity manager. Let's see, he's at 500, 500. So that should be 5, 5, I believe. Should have kept those text identifiers. So if we're at 0, 0, we're going to go to 1, 1, 2, 2, 3, 3, 4, 4, and now we should hit this guy, but we're not. So he's at, let's start him out at, let's see 100, 100, and see if what's going on here. Yep, there are 2. Okay, his position is the same, but his position is twice as far away as we would imagine it to be. Oh, sorry about the little background noise there. Let's see what we want to do in our tiles. Where's our map manager? Oh, don't open the map. Do our map manager. All right. We have generate map tiles, which is right here. And these are a 1-1 scale, so that's 100, 100. So putting yourself at 100, 100 should be on. So let's go here. Let's hit play and start. And we're going to do a eject. And this allows us to click on him and see the details. So he's at 100, 100. So we have this tile here. It's at 0, 0. This tile is at 100, 100. But he is also at 100 and 100. How does that make sense? Interesting. Let's see if we can. It says he's at 100, 100. And you're at 0, 0. The tile beneath you is at 0, 0. This is 100. This says it's at 100, 100. We have a static mesh. That's the static mesh component of the monster. Oh, the monster's over here. But all his components are over there. Let's look at the player. Yeah, the player is in the right spot. Interesting. So let's go to our monster. And, or actually, let's go to our entity here. And our entity, when you're made, you spawn components. And you spawn the actor. You attack them. Let's snap to target. So I think that's probably because we're spawning it and moving it, and then the components. So let's try and take a look at this again real quick. There you go. Now you're in the right spot. Nope, you're not. I think you're in the right spot. You're at 100, 100. It's just the collision isn't working. So here we go. We'll go back to our entity manager and say, let's put this guy at 200, 200, and position 2, 2. All right. So let's go up here, click start, and there you are. You can't move on to it. There you go. That's a, and we can make, right now it's not checking for what it is. Like if it's an enemy and we want to move on to it, we could make it actually attack them. But right now we're just checking the collision. So let's quit out. And the collision is working. It's preventing us from moving onto that guy. So what we're gonna do is we need to, we're not running off the event system yet. The movement system's still doing that tick. So if we're gonna sit here and say, where we're at, player controller. So the movement request is not valid. So if it's not valid, we still need to disable it. So we can set has movement to false. And oops. Where is that running from? That's from our movement component. Our player controller component, because this is the player controller system that we're working in. So it's going to tell them, oh, we have no more movement, so stop because. So now we shouldn't see that debug message pop up a bunch of times, just once, every time. There you go. So now we can make things like trees and stuff that we can't move into and slap them around the map. So there we go. There's our monster. So now what we want to do, and initially it probably won't look like much because there's not a lot going on, but this is a very important part, is we want to set up this movement request into our event system. So here we go, all the way back to the event manager. All right. Now the first thing we're going to need is basically a common or somewhat common data structure to use in the event system that can be made as a list. So we're going to go in here and in ECS, let's make a new folder. We're going to call this events. And this is just going to be a data structure. So blueprint, and we're going to make this a U object. Oh, it's not letting me do that in blueprints. This is a C++ thing I tried to do. So what's the most basic thing we can make? Actors. What else do we have down here? All sorts of good stuff. Can we do a collapse all? Nav areas, pawn actions, safe games, tons and tons of stuff. Visual. So we'll just make it an actor. That's one step down from a U object, which is very generic. Oh, can I select that? That wasn't letting me do that before. So event. Now we have a U object event, and this is basically a U object's pretty much like a structure. It's what everything else in the engine is based off of. So for our event, we are going to have several variables in here. The first one is going to be a integer, and it's going to be event time. We'll call it event time. And basically it's going to, like, let's say our movement event takes 100, time units of whatever we're doing to move, and that event gets queued in here. It's going to go in at number 100, so it's going to go after anything that has a number lower than 100, but before anything that has a number higher than 100. And whenever an event goes, like let's say an event that takes 50 units goes, it'll go through and subtract 50 from all those other events. So that's going to have the event time. And we're also going to need a reference to the system. So I'm trying to think if the systems can use their own events and treat them treat the events they get like a known event. But so let's have another variable here, and we're going to have the system that the event is going to get passed to, and this is going to be an ECS system object reference. So whenever they're created, whatever system is going to consume them is a reference to that system is going to be put in there. So the event can say, hey, it's time for this event. I'm going to send it to this system, and when I know what time. So let's go back and look at our ECS again, and our ECS system, the base class here we're going to have is, we don't want a variable. We want let's say this real quick. We want a function, and this function is going to be execute event. And that's going to take as an input a new parameter that's going to be an event object reference event. Now we're just going to leave that as it is, so the event manager can call the systems generically and just say, hey, pass your event to the system, and it's not going to need to worry about what type of system it is or anything. The system can handle that itself once it gets its event. So what we're going to be looking at first is we want to go back here and go to our not system. We're going to go to events, and we can create a child blueprint class, and let's call this a movement event. So we're going to save this, and let's add one more thing to our event, the entity, and the component. I'm not sure we'll need both of those, but let's make sure. I'm just going to stick that in there for now. And there's going to be an ECS component object reference. All right. Because it might be going to another entity or something, but that's in the base. So the movement one, let's look at what kind of movement we're going to be doing. So in the player controller, that's the player controller component. We have let's close the player and the monster and the actor macros and start looking around at what we got. We have a player control system. So what's this doing right now is getting the entity, getting its movement component, and it's adding a movement to it based on the an int vector. And it's saying, it's calling to the player move dispatch. And that's the control system. So let's do a find reference to the player move dispatch, and we're going to see exactly where that's being used in the map manager. So we're going to have to make a special event for when this happens, because we don't want it to happen right away in here. We want to happen when the movement system consumes it, basically. So we have our player controller system. Oh wait, that's in the map manager. Bind event to player move dispatch. Yep. All right, so we may have to move that, but that's all right. So what we want the direction, the int vector. So our movement event is going to have a new variable called the direction, and that's going to be an int vector. There we go. And the player controller is going to, so we're getting our player here. We're getting the movement component. And what we want to do is create an event. So let's see. Get the event manager. So the systems. Oops, get all actors. So we're gonna later on we're gonna do a little bit of work with references and things. So we're not gonna do all these get all actors of class type work all the time because they're a bit expensive. But right now that's what we're gonna use. So we're going to get the only one that exists, and we're going to get the events. Oops. And what we want to do is create a movement. Event. So our events here is event system. Oh, that's our event. The event manager has an event array. So we're going to add a variable, events, and event object reference, and you're going to be an array. So let's go back here to our player controller. And we're going to get events. Well, we actually need to what's it called? We need to have a function where we add the event so it puts it in the right, order in the queue and things like that. So we will pass in, let me see here. We want to go from this system to create an event, add it to the event manager. So I think this is why we're using actors before, because actors have extra stuff, but you don't need to use that. You can just use them as a data value. So let's get that out of there real quick. Let's go back and fix this. We're gonna change this event to event delete, and we're just gonna put delete at the front of the name because we don't want to remove it just yet, but we're gonna want to remove it soon. And delete movement event. So let's pick a blueprint class, a new actor, and we're going to call this an event. And we're going to create a child blueprint class called a movement event. There we go. Now we can look at our event that we're going to delete, and we have the time, ECS system, the entity, and the ECS component. So let's add those variables. Time, ECS system, entity, component, ECS component, and this is going to be our entity. Let's save that. And here's a neat thing. Let's just go look at this really quick. This is a neat part of Unreal. But I want to change entity to ECS entity, so it matches with the other things. So I can just go here, change that, and it renames it everywhere it's used. So I don't have to worry about it. So boom, there we go. And we have ECS entity. So if I go back here to the event, it's called ECS entity now. Excellent. So let's compile and save. Now we have our in our events, we have our movement event, and just like the one we're going to delete, it's going to have an int vector called direction. So we're going to have direction, and you're going to be an int vector. There we go. All right, compile, save. So we have event and a movement event. Now we need to change this in the event manager, which is, let's close this find. System manager, entity manager, event manager. So the events are going to be part of events and not, oops. Oops, I want it to be event. There we go. Event and not delete event. So there we go. We have an array of events. Excellent. So let's go back to here and see if we can delete these yet. Yeah, we can delete that, and this is the player controller, and the ECS system has a reference to this. So if we go to ECS system, we have an event. So let's just call this event. So we're going to replace that reference to this systems function. and the player controller is getting this as well. So we are going to spawn actor from class, and it's going to be a movement event. There we go. So we have our movement component. So we're going to set component. That's going to be our movement component. We're going to set entity. And actually, we could expose all these on the. So let's do that actually in the. Oh, it got mad at me. I don't have a transform. So if you split it, it'll just give you zeros, so you don't have to create a transform, which is nice. So we'll go back here to events, and all of these are going to be instance editable and expose on spawn. There we go. And there we go. Close that. And for our movement events, we want this same thing. So we go back to our player control system, and there we go. This is our component. This is our entity. That's the player. No, that's the player control object. So we want, oh yeah, it's getting the parent attached actor. That's what we're doing. That is our entity. That's correct. And we're going to do it to the movement system. And that system is going to be, let's see if we do, we really need to get IDs for these things. But for right now, let's just do, get all actors of class again. We'll set up IDs later for these system types so we can get them a little better. Get components, get systems and things by ID as opposed to searching or referencing them everywhere. So movement system, get, there's our system, and the time from our movement component. Nope. What do we call it in the components? Go back to components, the base components. Do we have a value here? No. In our movement component, we have a direction to move. What about the player control system? The player control component. I don't remember where we put the time to move. Move cost. Here we go in the player controller. So we'll make that an integer. I don't really need it to be a float. So our player controller, the player control system, and so its movement component. I guess that would be more accurate to have this in the movement, a move cost in the movement component. So let's get rid of that, and we're going to close the player control and go to the movement component, add a variable here, and type the move time. And that's going to be an integer, and we'll default that at 100. So everything will move at 100 unless it's otherwise specified. So we have move 100. Move time is 100 in the movement component. So our player controller system has the movement control component, and we're going to get the time from there. So we have our values set up, the time, the system element component. We've created this here. And this is going to be the movement event, but we're going to, that's what we need in the events also, is a player flag. B is player, it's a Boolean, So if anything's done by the player, that's when we see that event has transpired. We're going to stop consuming events and wait for the player to input something else. So here we can expose this, and we're going to be refresh all nodes, and yes, this is for the player. Excellent. So now we need to send this event to add movement component. We need to send this event to the event manager, and we'll create a custom event in here. So add event, and this is going to be an input of event object reference. It's going to be called new event. So we can go back to player control system. Oh, and we need to put the direction in here as well, because that is our move. So, and this is going to this can be called elsewhere. We'll figure out how to set up this dispatch, because when the event actually executes is when we want to run it, and that's controlling how our maps and everything moves. So this is our system. If we go and look at our base system class, we have a reference to the entity manager. We should get a reference to the event manager as well. But again, for right now, we're just going to do all actors of class event manager. Make a copy, add event, and this event we just created. So in our event manager, we're going to get our events, and we're going to go for loop with break, and the loop body, and let's see if there's anything there first. And so get length. Let's say length. If this is greater than 0, we're going to do something. We'll do all this fancy stuff. If it's not greater than 0, though, all we're going to do is go to events and add this in. Boom, there's our new event. So, but if there is other events here, what we're going to do is go to the first array element and get the time. And if this time is less than the time of this event we just brought in, so let's add a reroute node over here so we can keep it a little cleaner. So if the time of this event is less than, then we're going to go to the next loop. But if it's not, we want to insert it before then, basically. So let's say this time is 101, and this is 100. So then, if that's true, if this is less than, or no, if it's false, sorry. Let me reverse this. If this time that's coming in is greater than the time of this event, then we're gonna keep going. If it's, oh wait, let's think of the edge case. If they're both 100, I think that's why I did the less than the first time. So if the time of the current event is less than this event, we're just going to continue on. But if the time of this current event is not less than, which means it could be equal or greater. So we'll do a less than or equal to. So if it's less than or equal to this, we're going to place it after there. So whenever this happens to become false, we're going to add it in to here. So add in here, and we want to, let's do an insert actually, because we want to insert it at a specific index. So let's say this guy is, so this is the one where it's going to be ahead. So let's say this is index 10. We're going to insert it at index 10, and therefore it'll be ahead of there. So let's so let's say this is 100 and this is 100, so this is going to be less than or equal to, so it's going to insert it at that index, but we don't want to do that. We want to insert it afterwards. So let's just go back with the original less than here, and we can test this some later on just to make sure, or I'll actually check into my logic offline to make sure I'm doing this right. And we're going to do a flag here that says variable event was inserted, and let's make this a boolean. Oops, let's make this a boolean. Now actually, let's delete that real quick. What we're going to do is convert this to a function. So class to function, and we're going to, this is the same thing. We can remove this input, and this is going to override the function called add event. So we're just going to change the name right here, and this function is going to be called add event. So when we go back here to the player control system, we're going to add event, and we'll be looking at doing that right there, and the new item is going to be this. There we go. That'll be a little bit cleaner. So we have now in here, we can go inside this and add a local variable called event was inserted. We're just going to make this a single variable, and this is going to be default of false. So event was inserted, we're going to set it to true, and on completed we'll do a branch to check, was the event inserted? If it wasn't inserted, we're just going to add it right on the end. We do a false there, and we can just drag this on down, and boom. So either way, it'll get inserted at the right place or inserted right at the end. And now we want to do one thing. After all this is done, we're going to check if this event was a player event. So let's just bring this down here again. We're going to need to do this after any of the branches here, and if this inserts, we're going to break this loop and pop out here. So that's why I did a for loop with break, so you don't have to go through all the events if there's many events queued up. It's just a little bit of an optimization. So we're going to add a reroute node here, and it's C is player, and we're going to branch on this. So we're going to set a local variable and B has player event. And this is basically just going to, tell it when to stop consuming events. Once it doesn't have a player event, it'll stop consuming events. So, if we've just added, we want to know here. I'll say, we can actually instead of branching, we can just set this here if this is a player input. So if it's just added, we need this to happen. If it is, and either way, if it was inserted or if it was just added on the end, we need this to happen as well. So that'll update, and in our event graph, we can have here, we can have, oh, we don't want this called from inside, that's being called from outside the function. We can have a function called custom event and consume events. And this will go through our list of events and basically enact them until it doesn't have a player event again, wait for the player input. So we're just going to set up a do while loop here. We'll just call it a while loop. And while loop has player event. It's just going to run through everything. We're going to go to our events, get events, and we're going to get the first one. And we're going to, we want to get all the information out of this event. So let's take a look at the events, the time, system, entity component, and if it's the player. So we can get the time, get the system, and get the component. There we go. And get the player, if it is player. So we are going to take this event and say, let's make it happen, and we'll send it to the system. So the systems all have an execute event function. So what we can do in here is we grab this and we take it and say we're going to get the first event and send it over to the system. Now the system, knowing what kind of event it is, will be able to get any other extra information out of there. So right now we only need this 2 parts and the time. So what we're going to do is subtract the time from all the other events in the event loop, or the event array. So we're going to do for each loop, and in the loop body for each array element, we're going to set the time, and we're going to get the time. Oops. We're going to have the time minus, let's promote this to a variable so we can make sure we have the proper one here. Oh no, it's always going to be the first one, the 0, so that's fine. So we're going to take this guy's time and subtract the time of the event that's currently being evaluated, and set this new time, so everything's going to move forward ahead. And in the event manager, we're also going to have something called, like an elapsed time. And this will be an integer, so we can just add the amount of time that's passed by. So if there's anything that's dependent on how many ticks have gone by, or we just want to know how long the game has been going on, we can look at this variable. So we can set this before here because we don't want to do it a bunch of times. We just want to do this once. We have our elapsed time. We'll get the time out of here again. We don't need to worry about. Keeps it a little bit cleaner there. So that'll have Oh, so the problem with this is if we edit the time from the first one, it's going to mess up all the other ones. So let's just get we'll promote this to a local variable right here. Current event time. So what we'll do as soon as we get this event, we're going to execute it. We're going to set this time here so we can use it later on without having to worry about if it's changing. We're going to get it here. We're going to add it to the elapsed time, and then we are going to subtract the amount of time that has just elapsed from that event from all the other events. So any new events that get added in will get added in correctly. Now, when this loop is complete, if it is a player event, we're going to branch on this. And so once this condition goes to false, it'll stop and complete the loop. So if this is a player event, if this event we are executing is a player event, then we're going to set has player event to false, and then our while loop will complete. But either way, whether or not we're finishing the loop, we need to remove this event from the queue. So we're going to remove the index, and then it's going to be the 0 index, the one we just evaluated. So whether or not it is a player event, we're going to remove that item from the index after it's been sent and modified everything else in the event manager. And once the loop is completed, it's just going to stop. So here we have this, and if we're going to set player event to true, we'll check after it has set player events. If we are setting a player event, we're going to go in here and consume our events. So we'll just call that function. So there we go. Now we go back here, and we got to look at what we're calling where we execute event in the system. And the one specifically we are looking at is the movement system. So right now we need to have this come in and take a movement event and execute it. Basically do what it's already doing. So we can remove this from the tick. An event execute on systems. So this function here was intended to be part of the system looking at all of our what's it called? Basically if something like a hunger system and that wants to run every so many ticks, like the event system say, 1,000 ticks have passed. So look at all the components that are part of your system and execute something. So subtract stamina or add to your hunger or something like that. Make your character more tired or whatever it is. But what we're going to do here is just get we're just going to execute a single event as opposed to doing everything on the movement components. So this we can put up here, and we are not going to go through all the movement components like we did before, so we don't have to look at if it wants to move or anything like that. We're just going to executing a movement event that has already been validated. So what we got? We have the event, and it's going to cast to a movement event because we know we're in the movement system, so we know it's going to be a movement event. And we want to set a new position. Now, if we go back and look at our components, we have a collision, health, movement, player, position, and the static mesh. So the movement component should basically handle how the movement is done. The position component should be updated by the position system. So we don't have a system for each component. So right now we're kind of crossing over which systems touch on data and which components. And a good kind of idea when you're making an ECS system is to build this using kind of a one-to-one ratio of one system for each component type. So we may expand on that later, but right now we're just gonna kind of get things working, and we're gonna polish up the system a little bit later. We also need to look into some, improving some references and things, but it's not all very straightforward in how this works, because we're blending an entity component system into the Unreal Engine blueprint system, which has a it kind of has its own way of wanting to do things. So it's a bit of a hybridized system. So we're going to go back to the movement system here, and we're going to get an event, and this event is going to do all of this stuff that we have right here. So we're going to get the entity, and we're going to set the actor's location. So here, let me undo this real quick. There we go. I want to not break that. So basically what I want to do here is I don't want to ruin this logic that we already have set up in case we want to use it elsewhere. But I'm going to say, let's copy this over, and down here. So the first thing we're going to do is get our entity and set the actor's location. So get entity, get the move, get the direction. That's what we called it. If I could type it, there we go. So we're going to look at the logic here. We have the direction, which is coming out, and we're splitting it. We're doing the multiply, getting the actor location, all that good stuff, and we're rounding it and making it into a new vector. So let's get that same values here. We can split the direction. There are x and y. So we're getting it, we're rounding it to the nearest 100 and creating the vector, and now we're setting our new location. Let me drag these down. And now we want to, this is an entity, or no, we want the entity. So we don't need to cast this, since this is always going to be an entity, so we can just hook it up here to the components, and we're going to get the position components. Oops, we lost this. I think that was the entity. Nope. Let's do it here. So we're going to entity, and does have component. Let's call the proper function that we created, and position. So we're going to take the position component, cast to position component, and that's what we're going to have. So we don't need this loop or the branch or this cast here, because we're already doing it. So we're going to add our position to the current position. So we're here, and read the value of the variable position, and then we're going to add the direction. So this is the movement component reference, and this is direction. So our component is what we're looking at here, and we already got the direction down here, but we'll get, well, actually it'd be better to get the direction here, and from our event we can split this pin struct, because that's where we're passing the data from. So boom, Boom. There we go. Let's recompile. We need the target for the position component, which is that. And we can actually, since we're adding these, we made our nice little macros. We can add int vectors. There we go. Be interesting to see if we could name this with a special character. That's what happens with that. I've never tried that before. So we pull this out and it does a context sensitive. Yep, it just adds them. That's so nice. And we put it into the new position. All right. So let's see what happens. There was a lot of stuff to go through, so there may be some bugs in there. All right, we're not moving. So let's stop this. We're gonna, oh, we got the errors. And add event. What do we get? Access none, read in the player control system. So we didn't get this, or we didn't get the movement event that we just created. So we're not getting the event manager, which is, oh, it's not in the game. That would be useful if you existed. So let's make a new folder here, call it managers, and we can drag all of these up into here and save. All right, so let's try this again and see what happens. There we go. Woo! Whoop. We're not clearing out our request, it appears. So let's go and look. We'll open this over here, and we'll start, and we will well, you know, we'll fly out the side here, and as we're flying away, let's go and look at what's happening in the debug systems. Oh, we still have our oh, that's hooked up to the on tick. That's because we didn't do that. We can look at this, and this is running constantly. It's constantly being asked to execute the event. And is that because the event manager is constantly running? So it's not seeing, oh, it's saying it's to has player event is false. That's false. The loop body. But this is constantly being called. So consume events is what is constantly being called. So our add events is constantly being called. Now our add event is being called from the player control. And the reason this is being called continuously is because once we have added this event, we are not clearing out the request. So over here we have set has moved to false, but if everything works, we still need to clear out this request here. So let's just set that up and hit play, start, and there we go. Look at that. Now we're moving around the screen, and we've lost our map movement because we're not marking. Basically, the movement system is saying, hey, do the movement now, and we are not dispatching an event from the player controller, whereas the player has moved. So we look at this, this no longer exists, and we have our the bind event here in the begin play of our movement system. So let's just reference to self, bind event to player control system. So let's just cut this out here actually, and we'll take this to the movement system and go to its begin play and drop this in here. we want to look at the map gen, and this is actually going to be a movement system that we're looking at. So we can call that there, and we want to bind the event. We need to move the movement system dispatcher, or create a dispatcher in the movement system similar to this one. So this is player has moved dispatch. We can delete that. And let's go back to movement and create a dispatcher and call it player has moved dispatch. There we go. And we can call that here. And what I shouldn't have done is removed this. So this has the movement director and infector being passed to it. Okay, that's what I wanted to check. I was just hitting Control Z going backwards. So dispatch, we're going to create that, create a new infector, and that's going to be called player movement direction. There we go. So this is looking for, there we go. Now the players move dispatch, and in the map manager, here we are, we want to bind event to player has moved dispatch, and this is now from the movement system, so we're just moving this basically, and we can hook this up and get rid of this guy from the player controller. It does no longer exist. Everything compiles well. Now we need to actually call that. So the execute event here, and it executes and sets the position and everything. Basically, we want to look at this event and say, you know, is player. So if this is an event from the player, we're going to branch. And if it's true, we are going to call this. It's just like the way before. And we're going to have the movement direction passed in. So let's open this up, hit start, and now we can zoom out and move around. Oops, have a little bit of an error there, or maybe a big error. Let's see, it's giving us this crazy pattern here. Well, it's still colliding at least. That's interesting. And it doesn't stay the same. I guess it depends on when I change the direction I'm moving, and it'll grab that extra bit. So this shouldn't have changed at all, because we're just binding a new event, and it's still a move direction, and when it cuts from the player. So let's see here. Let's hit play, and we're going to just drag this out so we can look at the debug. And we'll just here, we'll move down. So we're moving down, and this is -x. But we're not finding, it shows we're not finding any tiles to actually move. It's odd because they are moving. On the screen we can see over here real quick, even though it's giving us the gaps, it's still moving the tiles down. So let's take a quick look here and see what's going wrong with our calls. So we're moving the correct amount. We're updating the position component. Oh, okay, so that's what the problem is. So we were moving, and then after we're moving, we are doing the call. And previously, we had been looking at it, doing it before we updated the position component. So it's getting the wrong values. So let's go look at the map manager, and right now we have the player position, and that is what we have. So it would be easier to do this before the position is set, so we can actually just go back here, and it would be a little bit cleaner. There we go. So we can switch the order of these things and just drag them over here and break, and make sure you break this so you don't get a loop, an intentional loop in your execution. And this is going to say, this is going to dispatch and tell it to update the map before. There we go. So we're moving. Look at that. All right, our map's moving with us. We can run into things, and we have an event system. Although it's just us right now, but it's still working. So there's the event system. It's functioning. It's not a great example of its use yet, but we're going to get further and further along with that. And we should be able to add some AI next time and see what's going on. But for right now, that's going to be it. And thank you for joining me in how to create a roguelike in Unreal Engine. As always, don't forget to commit all of your changes to your repository of choice, whether it be Git, Mercurial, Perforce, or Subversion, and hopefully back it up on an online site. So we're just going to stop for now, and I hope you guys join me next time in how to create a roguelike in Unreal Engine using only blueprints. Thank you for your time, and have a great day. Good morning and welcome back to creating a classic roguelike game in Unreal Engine. So today we're going to get started with a little bit of cleanup. Our project has grown fast and wild, and we want to start organizing things and taking care of some inconsistencies we made with the ECS system and some shortcuts we've taken in order to get things on the screen. So the very first thing we're going to do is go look at these entities we have here. And now, see, these are child classes of the entity class, and this is specifically something we don't want to do because we're not using a class system. We're not trying to inherit from other classes. And well, it works the same way because it's just an entity with a list of components. What we really want to do is make an entity just an entity with components, and its behavior is affected by those components, as opposed to making classes. So we're going to get rid of these classes real quick. But first, to do that, we need to make another way to spawn these and keep this information. So let's take a look here, and this has some starting values, and it has in our entity class, we can see it has a list of components and a place to store those components. So what we're going to do is, we can actually get rid of this later, but the first thing we're going to do in our entities, we're going to create a new structure, and that's under, if you right click in here and under blueprints, we can create a blueprint structure, and this is going to be entity definitions. So we can save that. Now we can open this up, and what we're going to do is just first we're going to put a name. This can be used as an identifier or something, and then it's going to call the string. We're going to add a new variable, and this is going to be called component classes, and that is going to be, if we search ECS component class references, and we're going to click here because we want to make it an array. So we're going to save, and now we have our structure. Now we want to use this structure to make a data table. So again, we right click in our content browser and we go to miscellaneous, and down here we go to data table, and we'll have a blank drop down, and we choose the structure that we just created, entity definitions. Click OK, and we're going to call this entity list. Save that. Let's open it up, and the first thing we're going to do is make a new row. And we're going to call this player. We can save, and we're going to add in the component classes that the player has, and we can look at class defaults here. And it has health, collision, player control, static mesh, movement, and position. That's 6. We're going to go from 0 to 5. So collision, health, movement, player control, position, oops, and static mesh. There we go. Then we're going to name this row player. Then we're going to add a new row again, and we're going to name this row monster. We're going to save it, and we're going to just call the name monster as well. And the array elements here are going to be like they were for player. We'll look at the class defaults and collision, position, static mesh, movement, and health. Everything except for the AI. So we can go actually into components here and go right click, create a blueprint, and search for ECS component, make a child class of that. And we're going to do make an AI component. Let's just save that. It's going to be empty right now and not do anything, and we don't have an AI system either. So the class defaults, we can look at these. We'll have 6 again, so we'll go to the entity list and add 6, 0 to 5. We'll have collision, AI, health, movement, position, and a static mesh. There we go. Let's save that. So now we have our entity list. So we can look here at the entities where we had a monster, and this was just assigning those default values. And for the player, the same thing. We were when we were spawning the player control player, we were attaching the we're doing two things. We were attaching the map manager to the player, and we were also attaching the player pawn to this actor. So the player controller component, there should only ever be one of them. When it's initializing, it should do this stuff itself. So let's go back to where we're creating the entities, and the ECS entity, or let's go ECS entity manager. Let's change these two just to match. We're going to go ECS underscore entity manager and ECS underscore event manager. So we do a Control Shift S just to save everything. So entity manager, what we're going to do here is we're getting the game state. We're finding when we start playing the game, what we're going to do. So we're going to, this right now is spawn actor player. Now we don't want to do that. We just want to spawn an entity. So let's spawn actor from class, and we're going to spawn an entity. There we go. And one thing we want to do in the ECS entity is just have a variable for its the entity manager, and we're going to expose this on spawn and make it instance editable. Oops, sorry for that noise. So now we have this, and when we spawn an entity in the entity manager, we should see this, the entity manager. So we're just going to give a reference to self here and pass that in. And we're going to spawn the entity and split this. Now what we want to do is pass in the name as well, the name of basically what kind of entity it's going to be, which is just going to determine some information about it, like, and right now we're just spawning them at a specific starting location and stuff like that. So all this information is in our entity list, but we want to tell it to spawn a player, so we just need to tell it to get the name, the row name. So if we go in our entity, ECS entity, we can have a variable, and we're going to call this entity name, and we'll make this a string. and we'll make this also exposed on spawn, instance editable. So in our entity manager, let's do refresh. We're going to spawn a player. So now the player, let's pull all this stuff out of here. Oh, not the player. And we're going to close this. Make sure we're not getting in the wrong thing. In the event graph, we are going to go and instead of using the component classes, we are going to use the component list from the data table we just made. So we can find all reference to these component classes, click the little binoculars, and it says, are these anywhere else? So it shouldn't be anywhere else, but we're just checking to make sure. So yeah, that's just in there. So in the entity, we can say get, or let's just look at our options here. We'll type in data table, get data table row names. We can get a data table row, and this is the name of the row to retrieve. So this is going to come in. We can convert the string to a name, and our data table shows up there as entity list. So we can look at this and say, here's the row name. It's going to be the same thing as we pass in. If we look here at our list, we have player and the monster. So this is going to go right here, and just that's all we need to do is change out where it's getting that information from. So now we have the row is found. If it's not found, we're going to do an error, print string. We'll make an append here, and this will tell us row not found for entity spawn with name. And we can just drag the name in here. We'll make sure there's a space. So that again, that should spawn our entities without, but they're not going to have any default values. So here we can start and we can see we don't have the default behavior coming from our entities right now. We're just, spawning them without anything. So there we go. Now, what we need to do is move the this information that we're assigning to the specific actors into somewhere else. But first, what we want to do is in the player, this is going to be the player control component, is we want this to handle the setup that attaching to the actor and stuff like that. So what we can do is just cut this out real quick, and we're going to go to the player controller, and on its begin play, we're going to get the player controller and the pawn, which, if you remember, our pawn is just the camera actor we're attaching to the little entity we've created, and we want to attach it to the parent. So the parent actor. So we don't want it to self, because this is well, we could attach it to this. Actually, we will leave it attached to the player controller, because that, this is kind of a neat thing about entity component system. If you ever want the player to control something different, we can just move this player control component from one thing to another thing, and you can possess that and take it over and run around with it. So we're going to save that right there. So that's part of it. Now the other part is, this is part of the map work that comes through. So we're going to go to the map actor real quick, and this is where we're getting the player. We don't need the player to be an entity, so we're just going to call this an entity. We're going to get rid of that value here, so we can delete that, and we can just pass this right out here and ignore this variable. player entity, we don't need a reference to it. We just need a reference to its position component. So we can, when we update the move component, we can update the map. The entity get component. We don't have a function in here like we have for the other one. There's some built-in functionality in the engine that's similar to what we're doing, but we're using our own ECS for this for a little more visibility on how roguelikes work in general. A lot of what we do here is transferable. You can make it in C++ or Python or something like that. So I didn't want to use too much of what was built in the engine and make it even more of a hybridized ECS. I wanted to try and make it as true as an ECS as possible, and that's more of what we're moving towards here. So we can see we're going to get the player, and this is being called when the player is created. So we actually want to, when the player controller is created, which is the component, we want to, do we have a reference to our component manager? Let's fix that up. So we're going to fix the chain of references so we don't have to do all these get actors from classes and things real quick. So we'll go back to ECS and we're going to make a new blueprint class. An actor, we'll just call this ECS just by itself. Now ECS is going to spawn these managers, and these managers are going to spawn their do their work that they need to do. So instead of just having them dropped in the level, we are going to have, actually, let's see. This is a finite number of managements, so we could have endless amounts of systems and endless amounts of components, but we're not going to have more system managers. Let me fix the name here to reflect the change in the class name. So what we're going to do is our ECS is going to be in here, and he's going to be hanging out. Let's bring him to the center. Right there at the player start. We got all these systems and stuff hanging out. Now our ECS, we can create some references here. So we're going to have 1, 2, 3, 4, 5 variables. And this is going to be, we'll call this systems manager. And we'll make the ECS systems manager object reference. That could be instance editable. We can look here, our ECS, and I have a systems manager, and we can just actually copy this one right out at the level. So this may be a good way to do it. We can make this actually also spawn these from a list of classes and do kind of a lookup like that. But for the moment, we're just gonna assume everything is placed in the level here. So we have our systems manager, so we want component, entity, event, and the mapgen actor. We'll do for map manager, component manager, entity manager, systems map, component, entity, and event manager. So this will provide a way of telling all these things, basically making an easier way for them all to look at each other as opposed to getting all actors of class all the time, which is expensive, and the more entities and components you have around, that can really slow things down. So actually what I am actually going to do is make this procedural, so we don't have to. All right, there we go. Let's do this. We are going to create a new variable and call this manager classes. and we're going to create a new class, blueprint class, actor called manager parents. Let's save this and we'll open it up, and we're going to give a new variable called ECS. This is going to be instance editable, expose on spawns, and it's going to be of class ECS. So we're going to save that. Now what we want to do is the component manager, we go file, reparent to manager, that's parents. And we're just going to copy this to make it easier to save. So we're reparenting the component manager to the manager parent class. We're going to reparent the map manager. And this is so we can all access them in the same way. So the entity manager, and the event manager, so entity event, we already got the component, the system, and that what we're looking at, the map manager, we got that. System, you can look at the upper right there to see the parent, event manager, entity manager, and component manager. All right, we got all of them. So the manager classes is going to be ECS, or it's just going to be, here we go, manager parents class references, and it's going to be an array. So let's set this up. We have the map, we'll do the map first, then we want systems, entities, components, and then events. So we can save that. So in begin play of this guy, we're going to drag this in and do a for each loop and spawn these in. So spawn actor from class. There we go. We can open this transform just so it works, and the ECS is just going to be a reference to self. There we go. So all our managers spawn and they all have a reference to the ECS, which has information about each other. So this is going to be, we're going to leave the list of managers in here, and it's going to be manager parent object references. So we can get this, and as these spawn we'll add, so we can keep track of them. And we want to add a function in here to get a manager of a specific type. So let's create a function and call it get manager, and we'll input a class of manager, manager parent class reference, manager type, and we're going to go to managers, or we'll go to manager classes. We're going to get it, and we're going to find in it this class. Oops. Once we find it, we will get the corresponding manager from this array, and we're going to return the manager reference. There we go. So that's the easy and quick way we can do to get the managers whenever we need them from other managers or even from manager children. There we go. So let's close all these managers really quick, and the parents, and we're going to save this. Now the ECS is in here, so we can actually just get rid of all these. And this might not work because there's a lot of other stuff going on, so the player's still not showing up, but we haven't just linked up that starting data yet. But we can see the managers all spawn in, the player, the pawn, all this other information is working. We have all the map tiles. So, and the components on the entities. So let's go here, and we're going to go back to the Entity Manager, and we're going to do the same thing here with the monster. And we're just going to spawn an entity, and the name is going to be monster. And we still want to do this. There we go. I'm going to add to the entity list, and you as well. And we still want to do this little bit here where we set up its position over there. Although on spawn it may not have that. That might not work because the position components are being created in the entity. So we'll just check and make sure that works in a little bit. So there we go. All right. So what we're going to do for this, let's just collapse this to a function. And we're going to say this create player. And we can create a lot of other functions for creating monsters and different types of things. But basically in here what we want to do is set up the data like we had before. And this is what the entity manager is going to help us do, is create entities of different kinds and things using the entity definition values we have up here. So if we go to our player, we look in here, and we're going to get health, collision, and static mesh. So 100, yes, it does collide, and we want the static mesh, which is the player shape. So collision, cast to collision component, and we can convert this to a pure cast. We know this is always going to have there, and we can set does collide to true. And we can also set this up as a sequence to make it a little easier to read, since none of these are depending on each other. A static mesh component and cast to static mesh comp. Yep, that's our ECS component. Then we want to set static mesh to be the player shape. And there we go. And we also want to do the health. But we can leave the default health in the health component is 100. So we can leave that. Oh, it says 0. Okay. Well, let's do that just to make sure in the future. So we can add another here, and it does have component health and cast to health. Pure cast, set health to be 100. There we go. Oops, and hook this guy up to the entity itself. All right, now let's hit play, start, and there we go. We have our player. Still not moving around and stuff. That's all right. That's because of all the other stuff we changed. So now we have our player again. So we're going to save that, and we're going to close the entity list and definitions for now. Now what we want to do is, we replace this behavior. We need to hook up the map basically to where the player control component does. And so player control is a component. Now the components are going to have a reference to the component manager, and that is going to be, oops, let's just type ECS. That'll bring up the list fast. object reference, and we are going to expose on spawn, instance editable, and we don't need that really quick. So the component manager is going to, whenever we spawn a component in the entity manager, we want, or in the entities, sorry, in the ECS entity is the one that is spawning the components. We want to add that value to the component. So this is an actor, it's a component class. This is saying actor class. So let's remake this node, and it's components, actor class reference, component class. Oh, that's the name. So add new component. Let's call this component class. Component. And its name ECS component. So we can go ECS class reference. So here, and there we go. We have the component manager. And we're having a problem here. And this is actor classes, out row component classes. That's because that is for each loop. Let's replace the for each loop. So these loops will define themselves by what you put in it. And if you put something new in it, it might not always replace properly. So this was still outputting an actor as opposed to the component class. That's all right. So that's working now. So in here, the component manager. So we have our entity manager from the entity. So we're going to get this guy and get ECS, and then get you see what the get a manager of the type component manager. Where is this? So we don't actually need to do that. The components don't need the component manager. The systems are what need the list of components that are relevant to them. So when the component spawns, it needs to find its system and register itself with that. And in here we have the register of the component, and that's got to be assigned in each component type. So the ECS component, it could have the component manager, and that's the way it goes back to find, but actually be more useful and meaningful for all components to have a reference to the systems manager right here. We're going to rename that system manager, and in our entity, when it spawns, let's refresh the nodes. Actor class. Why is it still here? Let's make a new spawn actor. There we go. So we don't need this transform actually, because we're going to be snapping to the target here. So if we, there we go, get ECS, get a manager of type, systems manager, and can pull this in. This is looking for a systems manager, so we cast the systems manager, split bin stroke, or convert to pure cast. That's what we want to do. There we go. So now it has the systems manager. We can hook back up this attach, and the components need to add from this spawn. So it's attaching to, and we're attaching this entity to the actor. There we go. So we're going to hit play real quick, and we got this guy over here. All right. Now we have the systems for each component, so the component is going to be able to register itself. So if we look at, let's look here at the movement component. Oh, here we go. It's registering itself here. So, but this is going to have a get system manager, get ECS. Oh no, I don't need the. I just need the movement. Get systems list. Oh, the system manager doesn't have a function for the finding something like the ECS does. So, oh no, that's the ECS system. We want the systems manager. So you can see here, this has the entity manager as well. So when we're spawning a system, we don't need a reference to the entity manager. We need a reference to the system manager. So each system needs to have a variable here and the systems manager. Then you're going to be ECS systems manager, object reference, save. There we go. And this will be exposed on spawn, instance editable. File, refresh. So we're going to remove this and pass in a reference to self. There we go. And this is getting, we're setting this here. And so we don't need this anymore. And we can remove that, and our systems do not need this anymore. We can find the references where it's used. Get entity manager in the player control system. So what we could do here is we want the entity manager, so we can get the systems manager, get ECS, get manager, and we want to get it by class. So we want the entity manager, and we can cast to an entity manager, a pure cast, and get our list of entities here. So now we don't need to find that and set it like we did previously. We're just getting our, oops, let me slide this right over here. A little more organized. Oops, what happened? Player, oh, is player specifying file refresh. And do a reference viewer and see what's still looking at the player control system. So we're going to look at removing the reference in the player control system. And where is that? So where do we go? Reference viewer, player control system. The player controller is getting the player control system. And oh, yeah, that's what it's doing. It's registering. That's good. We can fix up how that does it really quick, but we don't need to worry about it right now. But the player control system is what we want to remove this reference of player. And where is it? Is it still there? Yeah, in the player control system. So let's search and we'll find player cast to player. So we're just going to cast to ECS entity. And that's the one that does have the does have component function. There we go. We get rid of that, and now we can get rid of player because we don't need that class anymore. You can search and see it's not there. That's great. So you'll find this here, and we can delete. And it's going to say it has some memory references. So let's just we don't want to force delete and remove our undo history now, but we can just give this the name to delete underscore at the beginning, and the same thing with the monster. So let's go to here and look at a reference viewer. No, he's all set. So are you deletable? It still has some memory references. So we're going to leave him for a while to delete underscore and do Control Shift S to save everything. All right. Now let's go back here. We're just trying to get back to where we were. Oh, look at us. We're moving, but everything is wrong. So let's look at our errors. All right, we have tons. Access none, reading function, structure X. Yes, so the player position isn't going to be set because the player controller is what needs to call this value in here. So get player, find references, and we want to look for that. Where is that called? And that was in here. So we want the player controller to actually send this entity to our map manager. There's an entity, and we're going to get component. Those are actor functions. Did we ever make an entity function to get the components? No, we didn't. And that'll be just the same thing as like our this functionality right here, and we can pass that into entities just to get our components. So what we're going to do is set this up in the player controller so it can get the reference to the map. So we're going to get the systems manager. As part of the player control component. Where are we? Let's close a bunch of stuff real quick. So ECS component has a reference to the ECS systems manager. So every component has a reference there, and that's how it's going to register itself with its own system. So here with the player controller, we can get the systems manager, we can get the ECS from that, and we can get the map. Should be able to get the map manager. Get manager. And we're going to get by class and the map manager. And we're going to cast to the map manager. It's a pure cast, since it could be nothing else. And what we want to do is get player. We're going to call that event, and it's looking for the player. So we're going to get attach parent actor, and it's looking for the entity that this player control is attached to. So we're going to cast to entity and pass it in there. So now we can start. Oh, it still doesn't have it because it's not moving. So let's go and look really quick at what's going on in the or let's stop first and look at our errors. We're having tons of them still, I'm sure. So it's getting none. The player position component not being set, perhaps. Let's play again, and we're just going to quit right away. There's no errors. We'll start and quit again, and here's the errors. So in this, this is a generic macro, but let's look at our message log here. We're looking for a for each loop in the map manager, and it is the components, and we're not getting that from our player. So if we start and quit, we can look at the errors. So the player controller is being spawned, and it's not this might be running before it's getting attached. So let's see here in the entity manager, when we're creating the player, it gets created and it creates all of its own components. So it may be running that before it gets those. So let's just go here real quick. We're going to add a breakpoint, hit play, and see what happens. We'll start. And there's nothing being passed in. So if we go back and look at our player control, and we see, let's see here, can we, we'll debug the object, target the player. There is no get attached parent actor. So when this entity is spawning these components, it's attaching to actor, the self. So we're just gonna have to, we should be able to just give this a little delay in here in order to allow the player controller to catch up. So let's see if that works. It just may be in terms of a race condition. We can start here. Oops. We're going to remove this breakpoint. And, oh, there you go. Now it has a reference. So let's start and see what's happened. Oh, look. Now we can move around. Our wonderful little map is tracking with us. Just like before. We're all happy. So we're going to stop and let's start again really quick. Alright. So now to get back to where we are and where we were in the entity manager, there's still a lot of cleaning up we can do with the new system we set up, but we can do that as we encounter things and move along. We don't have to do all of that all at once, but we still have some more that we need to do with components and systems. So we're going to go into the entity manager and we're going to go to the event graph, and we are going to collapse this. No, we'll just leave this as it is right now. Well, let's collapse this down to a function, and we're going to call it spawn monster 1, and that way we can spawn a monster class and then set some specific things. So we can get this just like this we have here, where we want to set up the values for the player. We can do it for the monster class. So we're going to get the components. Collision, yes, it collides. Give it 100 health. We're going to give it monster shape as opposed to the player shape. There we go. And we need to hook all these up to the spawned actor. And this is just temporary, setting its position arbitrarily as opposed to procedurally, in order to just have one show up on the map and test out its behavior and stuff like that. So we'll compile, save, everything's looking good. Play, start, and oh, did not. Those collisions over there. So we're spawning the entity. We're spawning all these classes, but it's not snapping to the target. change this to always. Attach to actor, parent actor, self. Oh, in our spawn transform, we didn't actually move it. We set its position, but we didn't set its position properly. So we're just going to do this to 200 and 200, and it should be where it looks like it is. There you go. Everyone's happy. So we can run into it, we can move around, and everything's working like it was before. So now let's expand upon our systems that we have and kind of match up with our components. So we have 1, 2, 3, 4, 5, 6, 7 components right now, and a good rule of thumb, kind of, generally doesn't have to be true, but as you start building out something like this, we're generally going to have one system for each component type, a 1-to-1 ratio. And now we're obviously, we obviously don't have that, so let's make a new blueprint class, and it's going to be a type ECS system, and we're going to make a collision system. We can duplicate this and make an AI system. We can duplicate this. We're going to make a, what else do we have? Look at components. We have AI, collision, health, movement, position, and static mesh. So make a health system. We can duplicate and make a static mesh system, and we might not even use that one, but that's alright. AI, collision, health, movement, player, control, and position. Alright. So now we have 1, 2, 3, 4, 5, 6, 7, and the same as our number of components, 7 components, 7 systems, just 2 entities so far, and we have our little event manager. Let's see if we can delete this guy. Marked it for delete last time. There we go. Wonderful. Alright. Now, that's enough cleanup for the moment. So what we're going to do is let's start working on our AI system and see if we can get the monster to chase our character. So in our events, we have a movement event, and this is just the direction that it's going to be done, and it's part of the event. And we have flags here: the is player, the component, and the relevant system, component, and entity we're looking at. So what we can do is, let's say an AI system is going to decide to do something, and it's not going to decide to do 2 things at once. It's going to wait until its action completes and then decide to do another action. So we can look at our component and have our AI component, and let's add some values in here. So one is going to be has action in queue, and basically when it decides to do something and the event is valid and it goes to the event queue, we'll mark that as true. So it won't do anything until this AI won't try and do anything again until that's been validated, basically. So let's have another Boolean, and we'll just call this the is hostile, and we can set this to true. So the idea behind this is this is just data, this is a component, so we want our AI system to behave off of this. So this is our AI system, and we're going to have a get components. Let's see. Where is, did I spell that wrong? Our system parent. I don't believe ECS system. Yeah, this doesn't need to be set anymore because we set the systems manager as opposed to the entity manager and got that information differently. Let's just make sure we didn't break anything real quick. All right, there we go. Still colliding and everything. All right, so our ECS system just has the systems manager there. We can go to the systems manager and we want to add this is unhappy. There we go. Just reset and get that out of there. We want to add the new systems we have. So we have 7. And so we're going to have the AI, collision, health, position, and static mesh. So all these will be active and running. And the AI system, basically every time it's gonna go through here. Do I need this? I believe we don't need that variable anymore either. That's stuff from the one I deleted. All right, so you can look at our system, and the systems manager has and it should have a list of components. But what I did was, like you can see in the, let's go look at the movement system. One of the systems we already had running. And I made a list of movement components here. And the reason I did that was because, and I didn't want a list of generic components, is because I didn't want to have to cast to the component type. So since the movement system will only have a list of movement components ever, I don't need to really generalize that. It's not something that's going to be difficult to do later on. Now, so the AI can do the same thing. It's going to have a list of AI components. So we're going to get the variables and call it AI components. Compile and save. And this is going to be of type AI comp object reference, and it's going to be an array. All right. So now we have the register component from the component base, which needs to be overwritten. Well, we could do it a different way. It's basically let's get our systems manager and get system list. Or if we go back to the systems manager, we'll create a function here like we have in the ECS system to find a specific system. And we're going to get system input, a type of system ECS system, class reference, and this is the system we're looking for. And we're going to get this, and we're going to find this item. And once we found this item, we need to, here, let's promote this to a variable. This is going to be our systems. And we're going to make this an array. We don't need that. So we're going to get the array and add to it the systems as we create them. And that'll allow us to access those. So we weren't storing them before, but now we are. So get system is going to do this, and we're going to get it out of here. And we will have a return value of a system, ECS system, but it's going to be an object reference. So there we go. Just like we did in for the managers. So now we can close the system manager here. And where were we? In our components. So we can get a system. And our variables, we're going to have system, class, and basically each type of system will have its own class that it looks for. So we can get this. So we're going to systems matter get it, and then we're going to cast. Oops. Oh, let's rename this real quick, and we'll call this system out. We'll just call this system out. So in our components, we're going to cast to the type of system we want, but we want to cast using the class value. So we don't want to cast to the class. We already have a class. Well, we don't. Yeah, I guess we don't actually need to cast to a class here. So we are going to, in our ECS component, when we're registering, we're going to set this value in our systems. So our ECS system is going to have a list of movement components. So let's create a function where we add to it. We can find references, and we're just getting them here. So let's create an event. Let's just create a function actually, and add component. Nope, it doesn't like that because probably overriding some other function as part of the actor, so it's bad. Delete you. Let's create a function and call it register component, and the component is going to, oh, since we can't do this in what's it called, in the system, we need to do it in the system parent. So we'll create a function called register component, and that's going to take in a type of ECS component, object reference, component in, and so what we're going to do is, in each system, since we are defining the list of objects in the system, we can override the function called register component, and we're going to override this, and we're getting a generic one, but we're going to cast to a moving component, and we will add. Let's just grab this and do an add. So there we go. So now we know which type of component we're getting. And basically each component, so if we look at our movement component, one of the, that's a movement event, the values in these components, it's going to have a class default, so our system class is going to be AI system for the AI components. The system for the, let's open all of these at once. For our static mesh, it's going to be static mesh system. So that'll know, that'll get the right one. Position system, and the movement system. And this is our movement component. So it doesn't need to override this anymore. The ECS component base has this thing where it gets the system, there, registers the component, and it sends itself in. So every component will do this regardless. We just need to set the type of system it's going to be registering itself with. So there we go. So we can actually remove this override completely, which is nice. And we have our collision, so this is the collision system. There we go. And we have this, we have the movement system. Let's close out a bunch of stuff here. And the ECS entity manager, entities, we're going to go back here. So let's go to our systems and we're going to add our all of our arrays that we need. Oops, I didn't like what I did. So let me just drag these back into the same window. So the static mesh is going to have a variable of components. We'll just call these components because they're going to be of a static mesh type. And static mesh comp, that's the one we created, not component, which is the engine class. And it's going to be an array. And we can do the same for position system variable components. Make it an array of position components. There we go. Save. Static. Oop. There we go. I have that already. I think I missed one. Health system. Variable components. Is going to be a health components, an array, collision is going to be collision, component, and an array. Now, there's probably a, there we go, player control components. Now there is a better way to do this, I believe, after I added all these in. Anything we want to do in the components. So basically, the components should have a evaluate function. So if we go look at the component parent, and it's going to have a register function and it should have an evaluate function too. So when the system is evaluating a component, and it can call that evaluate function, and it will just run that on the component. But it still need to cast to get back the proper information. I'm just trying to imagine how you would set this up in C++ with variable, I don't know, it's arguments and things, but basically for right now we can leave this as it is. It's a bit of a, it's not the most cleanest, elegant method, but we have our list of components and stuff. So there we go, the movement system. So now what we're going to do, just to test out our AI system that we've created, let's go to play. We're going to start and let's look at our AI system, and we're going to be debugging. And we can't actually look at that because we don't have anything referencing it. But let's drag it out, get it, and get 0, begin play. We'll do a delay, and let's do a delay of like 5 seconds or something, just to give it a chance to. We'll do 3, and we just want to see that the AI component is registering correctly from the monster. So we'll just do something like get object name or whatever, and do a print string. And we can add a breakpoint in here to come look at it. So it's 3 seconds, so we'll go and start, and in 3 seconds we should get this. So there we go, we have our breakpoint. We have our nothing in our AI components. So this is our AI system. I'm going to stop. Oh, we didn't set up the register event. Oh, but that's the ECS system register event. Oh, that needs to be overridden in the AI system. So like the movement system, we have the register, which is set up here. It's overridden and it's adding it in. So the thing we need to do in the AI system is override this register I'm going to cast to an AI component and get this and add. We need to do this in all the systems as well. But for the moment, we're just going to do it for the AI one, just so we can. Here, we'll add a breakpoint here, and we can remove all this stuff. Let's just play and see. You know, this is going to get registered. So there we go. That's the one from the monster. So let's stop, and oh, we got a little error here. System manage register component. What does this say? Access none. Oh, that's because I believe we have, what is it here? Jeez. That is because all the systems aren't overriding the register component event, so it might be it. An ECS component, access none, trying to read property, register component, ECS component. So we are not getting a class here for some of our components. Let's go look at all of these real quick. The player control doesn't have the player control system class. There we go. So let's look. We might have missed it in another one. Class defaults. Thought I did that one. Let's hit play and see if we're missing anything. We can remove the breakpoint here and resume. No errors that time. There we go. All good. So what we want to do is this is what we're going to do to test out our AI and our event manager really quick. The AI, well, really quick. I should be so good, but the AI is basically what it wants to do is, you know, move east. So we're just going to have the AI system. We're going to override execute on systems. I'm going to get our AI components, and for each loop, oops, we don't want to break. We're just going to do a normal for each. I'm going to say, you know, does AI component has action in queue, not does. Has action in queue. If this is false, or well, we'll do a branch. We don't want to. We're not asking it. If this is false, we're just going to tell it to get entity. Where's our ECS component parent? So you need to be. Let's see here. Get attach parent actor, cast to entity, get component. Let's see, it does have component, and we're going to say movement component. Where is this? There we go. Cast to movement component. Well, let's see how we do it in here. So the player control system, it comes in, it checks. We're not going to check for collision right now, but we will say we're going to spawn a movement event and add it to the event manager. So this can get the ECS here. Oops. How come this is the player control system? So we can have a system manager. Get the systems manager. Get event. Oh, get manager. Oops. In our systems manager, what was that called? The function where we wrote to get system. Oh, let's just get system. Get system. Oh, and this, but that's not the event. We want to do the ECS. And get manager. And the event manager. There we go. And we can add the event right there. And let's just pull this guy out. Put this guy in. So what we want to do is create a movement event for this actor and flag that it has, it has something in the queue. So here we go. We have the AI. Oh, where are we? Our AI system. It says it doesn't have an event in the queue, and we are going to basically do what down here. It has a movement component, and we're going to get its system and use that to spawn a movement event. So we'll drag this in here. And what we'll do is also set has action in queue to true. First thing. Actually, we should set it after we actually set the action in the queue. So our system, this is going to be our movement component right here. Component. This is returning a actor reference. Huh. Let's make this an ECS component object reference. Got component. ECS component. This is going to mess things up. Components, these are going to be ECS components. Ooh. So this is just looking at actors still. These are components. So, oops, but that broke. I'm going to do a for each with break. So we'll replace these things one at a time. And the break can go up here. The array element is going to be doing that as opposed to that. And going in here as opposed to that. And the loop body will branch here, and the complete will branch here. So we can delete this, return it, and the component is going to be a component on the way out. Excellent. So let's go and look at these other ones. We're adding to the components. That's still set up. We just fixed that one. These are all good. The map manager. It's still treating it like actors, but that's okay. Just ignore that for the moment. The movement system. The components, all right, for each loop, that's still treating it, but that's just those things we can clean up as we come across later on. So right now, and this is to delete, so we're not too worried about this either. That's fine. So we'll close that out and everything is working. Let's just run a quick test. Oops. ECS Entity Manager has unresolved compiler errors. Oh, it does not like this. What have I done? The component no longer exists. Ah, that's why. So we'll just have to fix those up. Because I changed the class there. That's alright though. Not too bad. I'll hit play again on top. Movement system, player control system, and AI system. We just do that. And we can hit compile, and it just tells us right where it is, so it's pretty easy and nice. And our player control system has a whole bunch of them. We just drag this down to where the red line is and replace it. Where are we? There we go. And one more. Awesome. Let's hit play and just make sure we didn't break everything. Still colliding, moving around. Looks great. Alright. So our AI system, we're going to get, we're going to spawn a movement event. And we can just split this bin struct and we'll just tell it to go north. Oops, let's do 0 north by 1. There we go. The time it takes is 100, so about the same to move. So we're in the AI system, so we want to reference to self here. And the entity is going to be this guy. So that's all set up. We have the direction, and we can go back and look at the player control system to see it's sending this to the sending there and adding event. So let's go to the ECS Systems Manager, or back to the AI, and we can just drop this in here. And boom. Oh, we need to add the event there. All right, there we go. Now, we're passing an event, and so if an event, so this is not player. So in our event system, where's our event manager? It's not open. We'll go back here, event manager, and this is saying if it's player, have player event, we're going to remove blah blah blah. If it's not a player event, and we remove it, this is our event here. Let's do a reroute node to make this a little cleaner. Here we go. So we're going to get entity and get who does have component. And if it has an AI component, we're going to tell that AI that pay, oops, you no longer have an event in here, so we'll set that to false, and then we'll remove. Either way, we want to remove this, so if the cast fails, we will go up there. All right, so now it no longer has an action in the queue, so whenever the AI system runs again and executes on its events, it's going to look at all those things. So in our system manager, we can have a general, here we go, we'll have a general event. We'll get our systems and have a custom event that's going to say execute on all, execute all systems. And this is just, we might not use this a lot. We might use different groups and things like that, but we'll go through and tell each system to execute on all of its nodes. And if there's anything to update or do, execute on system. Oh no, let's just do our, what's this called? Execute on systems. That's a terrible name. Because like here we have, yeah, that's a terrible name. Let's call it execute on components. Yeah, I don't know why I named it that. That's absolutely terrible. So there we go. Now we have event execute on components. We can remove the tick out of there. We shouldn't be using tick in any of these. We have our own event consumption system. So this will run it. So in our systems manager, it's just going to go and event execute on all components for each one. And we want to call that from the event manager. Basically, every time an event is consumed, we want to say, hey, this go into anything? That makes me nervous, that tattooed out there. Event manager. So get ECS, the systems, get manager. I'll tell it to execute all systems. So yep, at the end right here, whenever an event is executed, we're going to tell it to execute all systems so AIs and things can queue up their next event whenever something needs to do something. All right, so let's see what's going to happen here. We may have some bugs, or we may have, oops. All right, so that's not letting me do anything anymore. So let's take a look real quick, and we'll do this. And we're not getting an input from the player control. Oh, is that because the event tick was still running this? Because I believe we weren't calling the player control system to execute as we put in when we put something in. So let's just hook that up back to event tick and see if that's what. There we go. Oh, and we totally crashed. Infinite loop detected. Not great. And where was that loop at? Let's go here. It started doing outputs, following call stack. So the player control system is receiving tick. The event manager was executing. So let's do this. And let's see what happens here. All right. Oh, having all sorts of weirdness going on. Still not allowing us to collide, but this guy isn't moving either, so. All right, so that's not executing the events properly. So basically what we need to do is look at the player control component. And this is going to get a value. Oh, this might be bad because we have the ECS component is doing its own registering of the player control system. So we do not need That ECS component is calling register component on a specific system, which needs to be overridden, but for this one it's not overridden, it's not doing anything. So the player controller, that's fine, it's adding itself to there, but the execute isn't doing anything. So let's go and let's see what we're doing real quick. So we're going to hit start and got our little dude. We're going to debug. So let's just move to the right. So we had that execute. That worked out just fine. The player control system immediately consumed it. The event manager. Let's look at your events. We have another movement event that is not being used because we don't have a player event. So that's false. So let's see here, let's move to the right again one. And we're left with an event. That's odd. It's ignoring some and using old input. So let me see here. This might be a problem with this little component hanging out that made me nervous. So let's fix this bug. We are looking at if the AI has an action queue or if we have a player event. So if we have an event, when the event is consumed, we're going to execute this event. And that's going to be in the ECS system. It's called execute event. That's going to be run on the specific system. So let's go look at our movement system here. Or no, that's our component. Systems, movement system. So we're going to execute event as a movement event. We're going to get our entity from the event. And if it's the player, it's true, we're gonna call and do all that stuff, but otherwise we don't want to do that. So we're basically not going to call that, but we're going to do the same thing here if it's not a player. So that guy should move and execute his event. But we're still getting some funky stuff going on. So let's see if we can get this guy to move. Nope. All right, we're still getting some delayed events and things. So let's see if we can take a look here. So we're going to debug on our movement system. And that was from the player. So no events are getting called from the AI. So let's say here the AI system. If you have an action queue, if you don't, we're going to get your entity, we're going to get your movement component, and we are going to create this event to move you in the movement event direction. It's not the player. And then we add it to the action. We add your event. So now this is the last values of everything that happened from that component. So our AI system does that. Now it should send this to the event manager. And we can debug here. So we have a whole bunch of events that have not been consumed. The time on those, that's not in scope. We can break these apart here and see their info. But we do have some elapsed time going on. Current event time is 0. We're going to move again. That's 0. Huh. And this goes and iterates through the events and reduces the time. And now we don't have any events executing that are not the player. For some reason it doesn't want to do this. So either, you know what it might be? It might be that, let's see, when I add an event, that's probably where I did wrong. So we have events, so these are probably all getting stacked behind. So in our events, we come in, if we have an event that's an array element of, let's say, let me write this out real quick. If the time of the event we're adding is 100, if it's going to be less than this time, so it's going to say false, it's going to insert it at this index and push it forward. And say the event was inserted. So if it's never less than anything, so let's say if they're both 100, it's not going to be inserted. And the event insert is full, so it's just going to add it, and it should add it onto the end of the array. Alright, sorry about that. So we had a bug, and I didn't want to read through everything while you're just standing here watching me think. So I just went and looked through, and basically what had happened is we added this here, which allows AI to add events to the event queue during the loop. So let's say the player is doing something really slow, the AI can choose to do and execute multiple events. Now the problem was that in the add event function, if it was saying if the event is not from a player, set has player event to false, because it's not from a player, so you're setting this bool value to false. So even though there may be a player event still in here, we were adding an event that was not from the player, setting has player event to false, and then the while loop would quit out without executing the player event. So we really only want to use this here to set the player event has player event true when the player event comes in. We don't want to set it to false in here ever. So basically this can only happen when it's true, so we don't ever want to set it to false. The only time we ever want to set has player event to false is in our event when we consume the player event. So there we go. So that will prevent it from that fixed the events getting not properly consumed while the AI was using an event. So if you fix that one thing, you just switch the order of these two. The events should get consumed and used properly. So let's hit play and hit start. And now we're just going to move around, and we did a move and then the AI queued up its move. So, oops. You can see it's only moving every other turn, which is interesting. It should be moving. It's moving as fast as us. That's true. Let's see if we can think about this. So it goes, we move up 1 and it moves up 2. So the events aren't getting queued in the right order. So let me look here. And this thing I was unsure about before, I think. So if the time coming in, I'm going to change this, is less than, if the time coming in is less than the time of the current event we're looking at, if that is true, we are going to insert it. Let's see if that makes it behave better. So it moves for every move we make. So every time we move up, it moves up. So now we have a moving monster. We can chase it around the map, and we just need. There we go. Move away. You can never catch it. You're too far away. So basically, we just need to set up the AI to say, "Hey, chase a system." So here we have our AI component if it's hostile. So the AI system can look and say, if we have an action in queue, it's false. Now let's say the movement event, the direction is basically going to depend on what it wants to do. Right now, the only thing we know about AIs is if they're hostile. So let's say we're going to look at we want to create the, this is something else I changed. I forgot. I think I edited this out. It's basically before we had a reference to self in here for the system, and this is the AI system. And we were passing the AI system into a movement event, but we wanted to pass the movement system into a movement event. So that's what we're going to do there. So we're just going to get the systems manager from this system and get the movement system and pass to the movement event. So it was passing it to the wrong movement. So I think that'll fix everything. We had a couple bugs there, but that works out now. So when we're looking at this, we want to choose a direction based on, basically what the component is. So if this AI component, we can drag this out here. We'll do a reroute node up above and drag it over and bring it right before we create the moon component, and we're going to say hostile. So if it is hostile, we're going to do a branch, and if this is true, let's say if it's false, we're going to have it move in a random direction. And we can do a random integer in range. We'll do -1 to 1. And then we can do, so we'll do, we'll move randomly up, down, left, right, back, forth, whatever, if it's false. Now, if it's true, let's copy this all up here. We want to make a move towards the player. Oops. Where's the target for that? So that's the target, is the AI component. So we can just drag this out from here. So this blueprint's getting a bit long, but that's okay. So we have our movement event, and now the direction we want to set is going to be from where is the player. So what we can do is, for the AI system, we can get the system manager, and then we get the player, or here, get system, and we're going to get the player control system. And now, since this one is there's only ever going to be one player controller, what we can do is cast this to a player control system and convert this to a pure cast and get the components and we can just get 0 since there's only ever going to be one. Oops. Then we can get attach parent actor. So that's going to get our basically it's going to get our player. There's another way we could do this is get the systems manager, and we could actually get the entity, or no, we get the ECS from here, and we could also get the entity, get manager. We could get the entity manager and search through all the entities for the player name. So you could target things with specific names or do things different ways. But this way we're just going to get, there's only one player controller, single player game, so we're going to get the player entity. I'm going to cast to entity. And since only our entities, we can do a pure cast. Building up our stack here. And now we want to does have component, and we're going to be looking at the position component, and there we go. As a position component, we're going to get our position. And what we want to do now, we're actually going to go back to our macros really quick, and game logic, macros, and actor macros, and we're going to add an int vector subtraction. So we're just going to call this minus int vector. Let's put names on these. It's a little better than just saying plus or minus, and it's unknown. But the minus will help us search for it a little bit better. So just like this, we'll have two v1 and v1 in and out. So new parameter, int vector, close v1, v2, and v3. And we can take this and, oh, actually we're gonna want to subtract it, so none of that's gonna be very helpful. So split this, and we can split this. So x, integer minus integer, x, y, z minus x, y, z, and we're going to use that to build our out z. So there we go. So that's going to be our subtraction for our integer vector. So we can go back here, and in our AI system, we're going to get the difference. So we want the entity from this guy, which we have. So we're just going to pull him out already. So we already got this and did a cast. So we're going to do does have component, and you're going to be the position component. And we will get the position here. So we're going to make them move in that direction. So basically what we want to do is have them move in a direction that'll be closer. You know, it can only be in one of 8 directions, so if you're off at some weird diagonal, we can't move, you know, specifically in one way or another. But what we should do is, so we're going from, this is the player and the entity. So we have, let's say the entity is at 10 and the player is at 0. So we want to move in the minus 10 direction. So it's going to be the player's position minus the vector of your entity. And we're going to use that to basically we have you know, that could be any number, and we want to kind of convert that into a unit vector. But since we have, let's see, what would be the best way to do that? I could make a macro, and that would basically just give us a unit vector from an int vector. Let's take a look at that. That's interesting. Unit int vector. So we're going to get our input is one int vector v1, and our output is unit v1. And this should handle all the we'll take the absolute value of all of these. Oops. It should handle all the rounding and everything and give us a good number, but we'll check it out. So we'll add these together. Add a pen here. Actually, let's see something. Recombine this and divide, or no, we don't have it. Break int vector x, y, z. Let's add another one here. We're going to do divide int vector by int. So we have our inputs is v1, and this is going to be v2, and this is going to be int. And we're just going to make this an integer. So v1, we can split this and we can divide all the integers here. So x, y, z, divide each by the same integer and recombine them. There we go. So we go back here to our unit, and we have this. So we divide by the magnitude. All right, no, we can't just add them because a squared plus b squared plus c squared. Apps. So let's just do this square. Oops. Huh. Doesn't want to let me do that. So I guess we'll just multiply. By itself, and we can add it in. There we go. ZZ, YY, XX. Now I'll take care of any negatives as well. No, we can't do a square root of the integer. Powers, no, nothing like that. So let's do load to float, square root, then to int. Or we'll just, I guess that's just rounding. So I'm gonna have to check that out. I just did all that off the top of my head, but that may be all terribly wrong. So there we go. So basically, that should work out, I believe, and that'll give us the unit integer unit vector. So let's go back here to our AI system, and we're going to be unit int vector, and we're going to pass that into the direction here. Let's recombine that and go here. And now let's see if our dude moves towards us. He's not doing anything. Let's take a look at what our system is doing. It's not doing anything. That's odd. It's saying it already has an action in the queue. Oh, I didn't hook up all the... That's the problem. I didn't hook up all these values. So this is the system we're looking at. Where's the entity? This is the entity we're looking at. And this is the component we're looking at. Not player. There we go. So let's start there. And he's still angry. Let's check our message logs. Poop. Let's just do it once and hit stop and get our editors. So it's a little bit cleaner. Spawn actor move an event. Did not work. What are we missing? This is our player. Let's just add a breakpoint here, and we're going to take a look, and we're going to see what we're missing and what we're not missing. So that's the position component from our AI, and we are not getting the player. ECS entity does have component position. Oh, position system. There we go, position component. So I guess that class hasn't been restricted to the component type, which is something I should do. So let's try this one more time. And see if we're getting it. It looks like, yep. So let's remove this breakpoint and resume. And we're gonna go and look. Now he's chasing us around. Oh, he got a little dumb there. Yep. He's closing in on us. That dude's following us. Now soon he'll be able to kill us. But not just now. Oh, we can move on to each other. So yeah, that he doesn't have collision. So that's something we'll have to work on. His collision isn't checked. That's okay. So that's it for now. Thanks for watching. Let me know if you have any questions, and next time we'll get on with improving the AI and beefing up player information and making the game a little bit more interesting. Thank you for watching. I hope you enjoyed, and join me next time in how to create a classic roguelike in Unreal Engine. Good morning and welcome back to creating a classic roguelike game in Unreal Engine. We're gonna jump right in, and the first thing we're gonna do, well, let's take a look at where we left off last time. So we loaded it up, and we have errors in here. So I'm gonna say no, we don't wanna play. And you may get these. When I loaded it up, I have two errors saying in our movement system we failed to import an ED graph from our macros. So you can click on the link in the errors, and it'll bring you to the class that has the problem. You can hit compile here, and you can see we have some problems. So let's go here and do refresh all nodes. There we go, that takes care of that. And here in our movement system, we're going to compile, and we get no errors there. So if we go look at this macro, we can see there shouldn't be anything wrong with that, but let's hit play again. We're saying we're getting an error in our ECS actor that's running everything. So if we compile here, we are failing to get the spawn actor of a class and a manager parent class, but this is spawning a actor. There we go. Okay, let's do this. Let's refresh all nodes and see if that clears up. Oh, it does clear it up. We can just break this bad connection here, and we'll recompile, and it should be running. So let's hit play, start, and again you can see we can't move into this guy, but he's gonna try and chase us around and follow us and everything. So whichever way we move, and now he's gonna move towards us. and we'll move over each other because he doesn't have collision right now. So what we're going to do is set up our collision system so we can take that out of the control. Like right now it's handled in the AI and the player control system. So the first thing we're going to do is go to our collision system, and we're going to create a function called get colliding entities. And what we want to do is, in our input, we want a int vector because that's what we're using for our locations. And basically what it's going to do is go through all the position components and say, do we have any, or all the position components, and say, do we have any entities here? And if we have an entity at that location, we check if it's colliding, and if it is, then we say you can't move there or attack or something like that. So there we go. So now we are in our collision system, so we can get the systems manager, which will allow us to get the entity manager. We have to call a get manager function. Let's go look at our systems manager. Oh, so I was looking at it over here. Sorry, I was in the other window. So basically, I just opened up the collision system in our systems here, and I created this function called get colliding entities. Now, if we go look at our systems manager back here, we can see get system is our function. So we want to get our entity system, our entity manager. Oh, well, let's get the ECS because we want to get the manager, not the system. So get manager, there we go. And the type entity manager. So cast to entity manager, it's going to be a pure cast because that's the only thing that should be returned. And we'll just stack this up right here. So once we get that, we're going to go over get entities. And this may not be the best way to do it because there could be a lot of entities without position information or things like that. So first, I'm trying to think of the best way to narrow it down. What would have the least? Well, what we should probably do is go and get all collision components first, and then check on position. So we can go to our systems manager right here, and we can get system, and we're going to get the collision system, which is going to have a list of collision components. Oh, right in our okay, sorry about this. I'm just jumping back and forth so much right at the start. So we're just going to go in here and get components, and we're going to do a for each loop. Now, one thing we have to do to make sure these components are in here is register, make sure they're registered. Like in our movement system, we have our register, where is it? Event register component, and this override, and when the component comes in, we're going to cast it to a moving component and add it. So our collision system is going to do the same thing in our event graph. We go override the register component, and we're going to cast to a collision component, and then we're going to add it to our components list. There we go. So now we have our list of components. On whenever a collision component spawns, it should add itself to here. So now this function can go in and say, in our collision components, do we have, just basically check, does it collide? So if that's true, then we're going to want to look at it. So we can take a branch from this, say if this is true, then we are going to get, oops, parent. Now we don't want to get attached parent actor, there we go. Cast to entity. And we're going to ask, does have component position? And every collision should have a position, but we're just going to cast here. So as our position component, we're going to get the position, and what we want to check is if our position that we're moving to is equal to this position. Now I'll add a reroute node. Now we can go add another macro to our actors macros because we don't have equals for our int vectors. So let's add a macro and equal int vector, and basically we'll have two inputs and an output, and b is equal. I put a b at the front of all the booleans because that's the coding standard for Unreal Engine. You can see when you actually look at it, the name represented here, it takes the b out, so it's not necessary. So int vector, and you are also an int vector. So what we're just going to do here is, since our integers already have a equals function, we'll just make 3 of them: y, z, x, y, z. Oh, we do. I already made this. It's called is equal. I just didn't have the I'll add that to the front right there. Let's delete that because we're just replicating. I should have looked a little more closely. So we can go back in here and just type in equal equal, and that'll give us, I just didn't add the operator symbol to the name to help me search. So we're going to branch and say if this is true. If this is true, we want to return this entity. So return, add a return node, and our output is going to be an entity. Search ECS, there we go, object reference, the collided entity. So we can just grab this and pass it here if it's true. If it's false, we're not going to do anything until we iterate through all of them. And we're going to come down here, and we can just use whether or not this is a null pointer as our success on collision. So if there's nothing there when it returns, we're not going to do anything. And if we do return, we'll break out of the loop and just give the first thing we collide with. So there shouldn't be two things in the same tile with collision. So now we can go back to our player control system right here, and where we have our move, so it says this is going to look at our movement component, or the player control component for our player control system, and it's going to say, do we have movement that we're trying to process? If it's true, we get the entity, and we're going to get its position. And basically what this is doing over here is everything we just did in there, but a little messier and longer. So what we can do is get a reference to the system, and we'll just get our systems manager and get system. It's going to be our collision system, and there we go. And now we do get colliding entities and at a location. So we're going to get the position here, and then we want to also add to it the move direction. So we have our position and the requested move input, and this is what we're adding. And basically this is looping through all the things otherwise. So this is what's going to go into our function, and this is what we're replacing here. You can see all this stuff up here. So let's pull this out. This is saying, do we have a collision component? Do we collide? And if at some point, do we collide is true, we set the move request to not being valid, etc., etc. So here we can just say, if this is a valid, basically, did we get something? We're going to say the move request is not valid, and you will collide. We're not going to generate a move event. Or now, if there is nothing that came out of here, we are going to go right down here to our branch, and then it says the move request is valid. We actually don't need this check anymore, but we'll leave it for now. So all this stuff up here is not going to be used anymore. Let's just move it out of the way, but we're not going to delete it just yet because we want to check and make sure that it's still working the same. So we just jump back in, and all right, it's not clearing the move. So because if we have a move request that is valid, it's going to be false, and it's going to have to remove that movement. So we hook that up there, and we can actually break this line just to keep things a little cleaner. So, and out here, the player control component, and there's only going to be one of these, so we could actually limit this down, but I'm just going to keep it the same so it looks like everything else. But I do want to clean it up just a little bit with this reroute node so the strings aren't going as far. And we have this guy, requested move input. All right. So this is going to say, hey, if your move is not valid, then boom, we're going to just basically clear that out. And so let's go back to the start. We're going to move, and we're going to, the move is not valid, you will collide, blah, blah, blah. We can't move into him. Excellent. So now what we want to do is say, if it is valid, we actually want to see what do we have here, and what do we do with this. So it's a valid entity. Let's get the entity. Or no, it's saying get entity manager. It's the entity, so we actually want to check if it does have a component. And the component we want is not going to be here yet, so let's go add a new component. We're going to add blueprint class ECS component type, and we're going to call this the combat component. And at the same time, let's make a system, blueprint class ECS system, and this is going to be a combat system. There we go. So the two things we're going to do real quick, just like with the other ones, is we're going to override the register and cast to combat component and add to a variable. Actually, let's delete this. It'd be easier to do is drag this out, promote to a variable. We can break it and delete that and change this to an array and just call it components. So we get it and then add to it. There we go. Now our combat system has our components, and we want the systems manager to spawn combat system that we just added. So let's add that in here. There we go. So now our combat system is integrated into the rest of the ECS, and our player control system is going to look here and say, do we have a combat component? And here we go. We'll do a sequence here because, oops. This is going to set, well, let's not do the sequence just yet. So if you do have it, if this cast failed, we'll just go back here because that means you don't have a combat component, and it'll just get rid of the move request. Now, if you do have it, we want to find out if what you're running into also has a combat component. So this is looking at the saying, hey, does the enemy entity have a combat component? And where are we getting? So if it does, and it's true, and the cast is true, we want to look at our combat component, and we want to send a combat event to the event log, which is going to be evaluated by the combat system at a specific time. So this is the thing we're running into. It has a combat system. If this cast succeeds, then we want to get the player's combat system as well. So we can, are we getting the player anywhere? Yes. So we're getting the attached parent cast to the entity. This is the player. So let's just, I'm thinking if we should promote this to a variable just so we don't have to call again, but let's just leave it as this, and we're going to do where do we have this? Begin overlap ticks, execute on components. So where's our, let's look at our player control component really quick. And we have this guy, and this is overriding the register component, but we don't need that anymore. We can delete that and go back to the player control system, and here we want to override the register component when it's called. So cast to a player control, and we're going to actually, let's find our references to this, and what we actually want to do is change this to a, let's make sure there's nowhere else. So it's in the AI system here. And the AI system is basically looking for the player. So we're going to, in the player control system, we're going to change this array to a single variable, change the variable type, and there you go. These are the two places it was being called. So we can just link this down now instead of doing this for each loop. So delete that. Oops. We had a bunch of connections, so we don't want to delete all those connections right away. So this is getting the parent, and we also have this requested move input coming from the controller, and also we have this to the reroute node that we built down here. There we go. So now we cleared out all these connections, so we can simply delete this, and that's just a little bit cleaner. So now we're going to set this. We have a reference to this. And what we can do, something useful here that, you know, stuff we're constantly repeating, is in our ECS, we can go to the ECS component, and we can create a function called get entity owner. And what we'll do is get attach parent actor, cast to entity, and we will return this. Return node. This will just help things be a little bit cleaner. And we can look for ECS entity object reference. And this will be entity owner of this component. Alright, so let's close that, and we'll go back to the player control system. So we can see here we're just doing that same thing, and we can now look at this components function and say get entity owner. And we can pass this in here. And boom. A little bit cleaner, a little bit nicer. So now the same thing we're going to do over here is player controller get entity owner, and we're going to say does have component, and it's going to be a combat component, and we know it does, but this gives us the value we need. So now we have two combat components, and this is the one we're running into, so that's going to be like our defender component, and this is going to be the one that is attacking. So let's go look at our combat component, and we can open that up and say in our variables we want attack, and this is going to be an integer, and we want defense. There we go. Now for defaults we can keep them as 0 and 0. But we'll need to set these in our ECS manager where it's spawning, monsters and players and things. So let's go here to our we have our systems and our events. So let's add we have movement events. So let's add a child of our event class, and we're going to call it a combat event. And we can look at our movement as an example. It has a direction here. So our combat event is going to have a variable, and this is going to be damage. And basically what it's going to do is apply damage to an actor based on the combat components that went in. So what we're going to need here is we're going to need the two entities, and we're going to need their health components, and we're going to apply damage to them. So the system that we want in our events, so like if we go back and look at the event base, it has the system, the entity, the component that is relevant. So it's going to be the health component, not the combat component. It's going to be the health component. The combat system is going to generate the event, which is going to be queued up, and then the health system is going to evaluate the damage. So there we go. So now we have our combat event, and we have the amount of damage, but we have the time, system entity, if it's a player event, all that good stuff. So we have that's our combat component, and we're going back to the player control system, and we want our combat system. All right, so our combat system, we're going to add a function and just call it combat, and we're going to take in two inputs, and they're going to be of the type combat component. We'll just call them C. We'll call it attacker and defender. Right now it doesn't matter. It could matter, but right now it doesn't. So get attack of this guy, and get the defense of this guy. So let's say our attacker has 5 attack, and this has 3 defense. We want to do 2 damage. So attack minus defense, and we're going to clamp it, or let's do a max. We don't allow it to go below 0, and so this is going to be the damage to our defender. And we can do the same thing here and get our defense from our attacker and the attack from our defender, and find out how much damage is going to be applied to our attacker, be it the person or the monster. Now actually we don't want to do both at once, because each one will be doing its own attack. So sorry, I was just thinking a little more redundant there. So basically we're going to have our attacker, our defender, and these are the component objects. And so this is going to be the amount of damage. So the combat system is going to create a spawn actor from class, and it's going to be a combat event. And let's go here, and we're going to make this editable, expose on spawn. So our combat system can see that. So refresh all nodes. Now, the attacker is the one that does the event. So our combat can come in and, let's say if our entity is the player, we could pass that value, but let's actually go into our components, the base component actor, and we're going to create another function here, and is owner the player. So what we're going to do is get the entity owner, we're going to pass itself, and then does have component player control, and if this is valid, then it is the player. If it's not valid, it's going to be not the player, so we can just add a boolean on return called b is player. So if this is valid, it's the player. If it's not valid, it's not the player. So that gives us a simple way to find out if the component we're looking at is from the player. So we'll go back to our combat system. There we are. And we're going to say is player. Oh, what did I call that? Is owner player. There we go. That makes sense. Is owner player. And this can just pass this in here. We want the amount of damage, and that's actually, we need to change the combat event. The damage needs to be an integer. So we go back to our combat system, do a file, refresh all nodes. Now we have damage. Combat events are by default going to be, let's call them 50. We can add the time into our combat event. The class default will be, where is it? We have time. Events have a time value. And there it is. So we can set this and basically say it's going to be 50 by default, but we can change that. Basically the combat component can have a time as well. So let's set that to be 50 by default as well, and we can actually grab that off the component. So if we want to make the player faster, we can edit its time, like if he levels up and gets to attack faster, stuff like that. So let's go in here and go back to the combat system. We will get the time from the combat component and pass that into the time. The system that we want to execute is going to be the health system of the defender. So get owner, and it does have component health system, and that's going to be, or it does have component health component. That's what we're going to be acting on. So if we go, let's go look at our event system. And close a few of these things, the macros, the collision system. Where we have here. Let's go look at our event manager and the event graph. And when execute event, the event is, oh, that's the ECS system. We're looking at event manager. Execute event, target is ECS system. So oh, the system is overriding it. That's why we don't have to cast to the system. I'm like, So the system is going to pass to the health system. So we need the proper health component, and we need the health system. to be passed in here. So we really need the system, and the health system is going to have to override the execute event, just like the movement system overrides it. So we go look at system. Our movement system has an override for execute event. It gets the event and it does all this stuff to move you around and does the dispatch for the player. So our health system is right here, and we're going to have to override the execute event, and this is our event. So get component down there, and this is going to be a health component. So we'll cast it to health component, and we will get this is going to be a health event or a combat event that we were evaluating here. So we want the damage, get damage, and health component we're gonna get the health, and we can set health, and basically we have the combat event. So the damage, our health is actually a float. So let's go back to our components and find our health, and we're going to set our health to be an integer. There we go. So in the health system, so health minus the damage is going to be our new health. And now let's see if our health is less than 0 or less than or equal to 0. We basically want to kill this entity, and we can set up more on this later. So there we go. We have the combat event, and what else we can add with the combat event is the attacker. And let's cast this to the entity. There's an ECS entity, object reference, and that will be set when this is created. So our combat system, refresh all nodes, and it's going to get the attacker. So our attacker, we're going to drag this out, get entity, oops. We're getting the entity owner of the defender there. So we want to get the entity owner of the attacker and pass it to here. The entity here is the entity owner of the defender, and the system is going to be the health system. So we can get system manager and get system health system and just pass that into here. And there we go. So this is giving us an error. Oh, the transform, we can ignore that. Just set it all to expand it so it sets it all to 0. So this is going to create our combat event. The combat event is going to go to the event manager and get plugged in. Now, the event manager is going to call the health system, where the health system is going to subtract health. And now we're going to say if something has less than health, we're going to kill it. So we have our the event, and it has the entity which is being hurt, and we can say, is this the player, or is owner player of the entity. ECS entity object reference. Oh, we're going to say does have component because it's not the component. So do we have a player controller? So if you're dying, if we do have the component, and if this is valid, that means it's the player. So we want to get game state cast to the roguelike game state and change game state to lost or dead. There we go. So if your player dies, let's see, we're going to do that. So now, this is something else we can do that's useful. We did this in the UI macros. If we go look at our macros, we have update game state, where basically it's doing, you know, all this kind of stuff, and we can do that for the actors as well in the actor macros. But we're not going to do that right now. That's something you can do if you want. But since we were calling in the health system, you know, to change the event, so that's the thing that's getting damaged. Now, if it's not a player controller, what we want to do is, let's put this down here. We'll do a reroute node to make it just a little bit cleaner. And we want to say does have component AI. And if it does, what we're going to do is destroy that component. But we also want to give the attacker, you know, experience, stuff like that. So let's do this. We don't have like a level, an XP component yet. So let's do this. We'll go components, blueprint class, and ECS component. Select and pick a level component. And we can save that, and we'll go to systems and blueprint class, ECS system, and we'll select that and make a level system. So we can go here to the system manager and add this class in so the system spawns. There we go. Level system. Now we have in our combat here, so let's do this. When our health is, basically we're going to kill the AI of anything we kill, and it's just going to become like a dead actor. It's just going to sit there, dead body. So but if we die, we lose the game, go to dead, and we have to go back to the main menu and stuff like that. So, but we're not going to do anything with the level system right now. But let's close a few of these just to keep things a little more organized. Just you can middle mouse click out there to close. So we're going to go back down to the main menu, and we're going to hit our entity manager. Oh no, we want to go to our entities list here and our entity definitions. Oh, not the structure, the list. And so our player is going to have a combat component, and it's also going to have a level component. I just called that level. It should be, let's go fix that name. Yeah. So that's going to have a combat and a level component. The monster is just going to have an additional combat component because we don't need to worry about the monsters leveling up. We could make a monster that levels up just by simply, you know, adding that component to them, which is nice. So let's see if we can delete, while we're looking at the entity list here, let's see if we can delete these. Since we loaded them last time, there's no more memory references, so we can just get rid of those. And now we have the, we just went and updated entities to have these proper components. And we wanted to fix the name of level component to be level component, just so it matches the rest of them. All right, now let's see if we can attack each other. And we'll go back to the system real quick in our health system. And whenever something gets hurt, we are going to print a message to the screen right here of how much damage occurred. So what we need to do, so the monsters can't attack us yet because the AI system isn't going to be doing anything. But the player control system, here we set it up so it says, do we have, this is our player control component, we have a combat component, and this is the enemy's combat component of something we're running into. If both of these exist, we are going to get the system manager, and let's get system, and the combat system, and let's see, what was the name of the function in here? Combat. That's easy enough. So we'll cast this to the combat system and call the combat function. There we go. So our attacker is here, this guy is the player. It wants two combat component references. So we will cast these, the combat component. And we can do the same thing with the other one. Oh, we need to check if this is valid. So we'll do the same thing where we cast here already. Because if it's not valid, like you could have an effect that basically removes the combat component from the player for a little while, disables them, for whatever reason. But we have our attacker and we have our defender. There we go. Now, once this is done, we're going to go back in here, and that should execute. And this is going to say, yeah, we don't have movement because we have combat. All right. And that will send a player-based combat event. So let's see if we can hit, the AI system has an error. Let's go look at this. We have, oh, we never changed this to basic, we just removed the array. So there we go. Compile, it is fine. So let's play, we're going to start. And, oops. It says this move is not valid, you will collide. So we're not engaging in combat here, and we are still hitting each other, and that's because I didn't update the AI control system. But it's not letting me it's not letting me attack him. So we've got some errors. Ooh, that's a whole bunch. Let's play again real quick, and let's do one move, and we will stop, and we got an error, and oh, this looks, I guess this is an event tick. Yes, the player control component is not valid, and that's because it's not registering itself right away before the system. So we can we need to do we need to have an execute down here run. Basically, instead of running this on event tick, whenever it receives player input, we'll go in here and check stuff, as opposed to just running it off the event tick. So let's go here, we'll close. Still getting this error, but the register component is failing, and we're at the system manager, get our system class, and that's in the ECS component is not set. Oh, okay, so our player control component does not have, oh, it does. Our AI systems class default. Let's close these systems out real quick. And we're going to make sure our components are registering themselves correctly. Collision component registers to collision system. Combat component needs to register to the combat system. The health component is registering to the health system. The level component Drag this over here is registering to the level system. And what else we got? Our movement component. Yep, that's good. These all should be good. I'm just checking to make sure. There we go. Static mesh. All right. So let's try again. Oops. Let's undo. Click this simulation button and just play. Let's quit out. Okay, no errors so far. We'll start again, and we can move. We'll quit out. No errors. Go back to start. We'll move once again and move into them. And it's saying move is not valid. You will collide. Okay, no errors, but basically we're not getting to the point where this is telling us what's going on. So let's add we're going to hit play. I'm going to drag this to the window, and then we can choose the system and see how this executes when we move into them. So right now I'm going to start, that was a move, so I'm going to move into him. So it's saying this move is not valid, you will collide. And it should be generating a combat event. Oh, we're not we're not sending it to the event manager, just like in the movement system. So our movement system is here. We get a thing, and it says the player control is where we're doing this. So this is generating it, and it says system manager, get manager, add event to the ECS manager, and we could probably make this a nice little function in the system's parent, which basically says get event manager. So we'll go back here to our ECS and ECS systems, create a function that says get event manager, and what we'll do is get the system manager, get the ECS, get event manager, or get a manager using its function, and we want the event manager, and we'll cast this to an event manager, and we can return this. So let's make a return node. Oops. And actually, let's go look at the movement, the control system real quick. So what this is doing is just adding event from the event manager. So we could add an event from the system, and we don't even need to, get this out, make it a little bit cleaner. So this, we can just do add event, and instead of a return node, we have input as new event, and this is going to be an event object reference. There we go. So that'll pass it right in. So we just can do add event from our any ECS system now. So here we see in our player control system, we can just call add event. Oh. Where is it? ECS system has a function called, I would call it get event manager. Let's just call it add ECS event. There we go. Much nicer. I didn't change the name of the system or the function, so add ECS, call this function. Target is going to be self, the return value is going to be the event, and we can just bring this back down here, and we can just get rid of all this mess. Very nice. So we want to do the same thing here with the target. Oh, the target is the combat system. So we're going here, and this wants, we want to add event here as well, which is very nice. So boom, snap it in there, and that should add the event, and the event should then be executed. So let's go and see if we can move. So yep, I did 0 damage. And you can see the guy's moving on to me, so we can just set that up. So I'm doing 0 damage because all the defaults for attack and defense are 0. So let's go into our entity manager, and we are going to create the player. That's interesting. Oh, that's because we changed it to an integer. So let's just refresh all these. We'll call this 0. Then we can right click on this, reset to default, and it will disappear. So where else? The monster as well. So let's give the monsters, 50 health, whatever. And the monster is, does have component, and cast to combat component. We call this combat as well. And we can set attack and set defense. This is for the monster. So let's just give him 10 attack and 5 defense. And we'll add a sequence here to set this up as well. And we can just do the same exact thing here, copy this into the player setup with some different values. So when we create the player, we can make the player a lot stronger. He'll have 15 attack and 8 defense, so the monster should still be able to hurt him a little bit. There we go. That should make no zeros popping up. So let's play real quick. We'll start, and we can see, oh look, I did 10 damage to him. Let's tell me, we can get rid of that. This is not a valid move. Ooh, we have errors. Where are we? In our AI components. Why didn't it like that? Attempted to access AI. Oh, it's pending kill because I murdered it. Let's go to entity manager, and I never, oh, it does have 100 health. So let's do this. I did 10 damage. And we'll do still moving. Oops, there we go. Now it's gonna be dead. It should be getting destroyed, but see, it's not following us anymore. But we will have some errors because we destroyed it, and it's actually looking to here we go. The AI system has not removed this component. So let's just add a check in here, and we're going to do a valid. And if it's not valid, I don't want to mess up the loop. Components to remove. So I don't have to loop through it twice. I'll just remove them afterwards. But we'll make this an integer array. And when we execute, we'll get it, clear it. And on finish of this loop, we'll do a for each loop of this, then remove Now let's just make this AI components. We'll make these change the variable type. There we go. So this is something we should set up actually in the system parent. At any time the event execute on components, add a call to the parent definition, and that basically checks through its components and checks for any invalid ones and removes them. So we're going to take this extra stuff out of here. We can add that in a little bit. First, we're gonna make sure we go through here and finish. What's it called? Finish the AI behavior basically the same way the player is set up. I have a little breakpoint left over here that's not triggering. So we have if you're hostile, if you're true, we want to find the player, get their location, and move towards it. So in our player, we're checking first and saying, you know, this is our movement event. So the system, the entity, and the component. Let's get the time for this. Get the move time, and we should hook that up into here as we're spawning our movement. So basically, first we're looking at where we want to move, and we're going to say, just like in the player control system, the first thing we did was get colliding entities. So our AI system, we can get colliding oops. Let's drag this out a little bit further. See, if you're not hostile, it's going to do a random movement. But we also want to get colliding entities there. But we might have other events and things, so we don't want to put it before the branch because we don't know where we're moving. So we need the direction to be checked. So we're going to get our systems manager, get a colliding entities. The collided entity, so the location is going to be where we're going to. So let's take this. This is looking at the position of our player and moving towards it. This is looking at ourself, or the AI, as it were. So this is its position, and we're going to get the position, and we need to add to it its movement direction. So that's going to be here, what we're pulling out. We can grab that back. So movement, we're going to add these two. That's where it wants to move. Now, if there's something valid, we can't move there. But if it's not valid, we'll do that. So there we go. So right now, we're not going to have it path around anything. We'll just say, you know, you can't, you know, move there if it's not valid. Oh, if we're not a hostile thing, we can do the same thing here in our systems manager. And basically, we need to get our own position component like this. So if we say false, we'll go down, get our system, and we will say first we need to get the component, the movement component from our own entity, which is this guy. That gets our position. Now we're going to add another int vector, which is going to be defined over here. So let's make one, make int vector, and we can call this, we'll promote this to a variable, and we'll call it wander direction. We'll set the wander direction, and then we'll find out if our position in the wander direction does have a colliding entity. We'll pass in that location, hook those up, and if it's not valid, then we can move. And then we want to pass the wander direction in here. We combine the pin struct, and there you go. Then it can wander around. Although there's no wandering monsters yet, but that's just something neat we can do. We can put a cow in the game or something. So here we go. Now it says actor's movement. Now if it's not valid, so if there's a valid collider, we want to check if what we're hitting is the player. So is owner, or owner, well, that's the collided entity. So we'll check that it does have component. player, oops, just that Y, player control, and do a cast. And if it is valid, or we don't even need to check if we don't need to do a cast, we'll just do if it's a valid, does have that. We can get this entity, and so we can get the combat, or we want to does have component, and it's going to say the combat component. And what we're going to do is, just like in the player control system, we are going to make a call the combat system and make a combat event. So back in the AI system here, the defender is now going to be the player. Let's cast this to a combat component, or we'll do a normal cast, because that will also tell us, if it's true, then we don't need to worry about it. So the player is now the defender. There we go. So it is the player, and it has a combat component. So we're going to get this, but we also need the attacker, which is our attacking entity. So we have it here, which is being dragged out really far. So let's get our entity, and we'll drag this one out and say does have component, and we want the combat component, and we'll do a cast. And if that is also true, we can have our attacker. So both of these need to be true. So there we go. And that'll send this into the combat system, and we should see some 2s. The player gets hurt. Yep. Player is getting hurt a little bit. Oh, it looks like that's interesting. Now it's dead. Let's go back here again. So we're getting hit once, and then we get hit twice, get hit 3 times, get hit 4 times. So there is an error, it looks like, in the event manager. Possibly it's not removing the what's it called? It's not removing the combat event for the sorry, it's not moving the combat event for the AI, which is odd. So or the time is very low. So no, the time should be the default, the combat components, because I didn't change that for either of them. Yeah, that's going to be 50. There it is. So first things first, we're going to go back into the systems here, and we're going to add a check for on execute on components, and we're going to, oh, we don't have the component list in the what is it, in the parent event. So we can add a function that takes a component array and does this. So let's create a function, and we'll call it, remove invalid components, and this will take an input of components of type ECS component, and it will be an array, and we'll do a for each loop. I should check the behavior of this and see if you remove. Actually, I don't think we need to do this, because the behavior of the for each loop should continue to iterate properly if you remove a component. So let's just see what happens here. We're only gonna have one AI right now, so see if it's valid. I'll need to test out this behavior, but right now, if it's valid, we can do this. If it's not valid, we will remove item. Remove all instances of this item, specific item from the array. Let's see if we can do something a little bit. Remove. Yep. Remove an array of items. Remove all elements in an array from a set. Or I can remove all instances of this item. There we go. So if it's not valid, we're just going to remove it. And there we go. So we should not get errors anymore when we kill our AI. It's following me around. Oops. Well, that's not right. He's not colliding with me. Now I killed him. So, let's see here. Oh, I died too. We're going to start over, and that stuff's still over there. We haven't done a cleanup. So yeah, he's just there. He's just getting beat, even though he's got. I guess I can remove the combat component also when these guys are dead. So that's interesting. That's what happened to Lost, and I had to continue. So let's close this real quick. We're going to start again. And what I want to check is, one, we still shouldn't be overlapping each other. So we look at the AI system. It's saying the move, if there is a colliding entities, if it's not valid, we'll do a move. If it's valid, there is one. So we're going to create the move. Oh, so what's happening is that when it's requesting the move event, it's not doing. Haha. When it's requesting the move event, it's saying it's empty and valid, but when it tries to execute the move event, so the movement system is where we're going to have to do some more of this. So I guess we're going to have to do another set of checks, because we don't want things to waste their turn, walking into a wall, but we don't also, want things to overlap each other, obviously. So, all right. So that's something that's going to be a bit bigger thing. We're going to have to, we'll try and organize that and maybe reuse some of this information. But for right now, this moment, what we have set up, we need to go in and check the event system to see what's going on with the enemy attacks and why they aren't getting cleared out of the event. So let's go in here and add a breakpoint. I'm going to hit play and start. And I'll go over here and move in. So these are just the movement events so far. Now they're both right next to each other. They should be attacking. So let's see what happens. So we have two events, both combat events. The first one is most likely me. But if we do resume, there's the attacks, the two attacks. Let's go here, and the two events in there. So, 2 and 3. So let's attack again, and we have events 2, 3, and 4. So it looks like they're going to get 2 attacks now. Let's resume. It has 5, 6, now it has 3. So I guess each time, okay. So what I believe is, whenever the AI component, so if it's not the player, it says AI component and it says don't have an action in the queue anymore. Huh. That's interesting. It looks like it's adding extra events. All right, well, we've gone on for a pretty good while. No, actually, just so we can wrap this up, I'm going to take a quick break right here and figure this out so I don't have to drudge through everything on video, and I'll be right back to show you the bug that we are having. All right, I'm back. Sorry about that. Something very simple, just in the end here, we forgot to add has action in queue for the AI. So the AI component will just get a reference to this guy all the way back here from the loop. There we go. So now when it runs, it shouldn't allow itself to queue multiple events because it has an action. So we can actually add the ECS event here. We can actually replace this, which would be great. Just a little, make everything a little cleaner. Close that up, and there we go. Beautiful. So yeah, we just create you know, functions where we see the need and replace them as we go along building, so we don't have to go through and refactor our code a whole bunch all at once, and then go through and do it again if we decide to change something else. So, you know, once you have your design complete and your game complete, you can go through and do that kind of optimization, but for right now we'll just do it as we encounter it. So let's hit play, let's hit start, and then we go here, and we still have that breakpoint set up, so let's right click in here, remove breakpoint, and resume, and we'll take a look at our little guy. We're standing next to him now, so I attack, do 10 damage to him, he attacks, do 2 damage to me, I attack, do 10 damage to him. Oh, he's not hurting me anymore. It's like he died right away. Huh. Let's check this real quick. Or he got stuck with his action in the queue, and the fix didn't really work. So our AI system here has action in queue. Is false. So let's do. Let's play again really quick. Let's make sure we're not doing something silly. So, you know, we both attack each other here. And let's look at this. The AI system. So it still has an AI component. It's valid. But it's saying it has an action in the queue. Because in our event manager, it never updated that. That's odd. When it consumed it, if it's not from the player and it has an AI component, it should say it. So it's still alive. It's just not doing anything because it believes it has an action in the queue. So our AI system is not running. So let's see here. Set this true. So yeah, anytime they do something, they add an event, it's going to say we have an action in the queue. So it added it went and did a combat event. So where else are we? We need to clean up all this stuff eventually as well. We can improve that a lot, but no need right now. So we're setting as action in queue. Now the event manager should remove that. So when they attack the combat system, if you are the player, and basically that's saying the attacker is the player, so that shouldn't be true. So let's add a breakpoint here real quick and check this. I'm just gonna have them run into each other. So spawn actor combat event, and this is false. Let's add a breakpoint and jump to that. So that's false. So let's remove the breakpoint. So if we go to our event manager, and we can drag this out and see here, we have events. There's no events because that's got to add it still. So we can go back. Where's our combat system here? All right, so let's resume. So there's a combat event, but it's waiting for me to do something now before his combat events execute. But it's going to hurt me before I hurt him. So I'm going to move into him again, and we have our add ECS event. That's the player that's going to add it. So what's going to happen is the AI is going to attack me. Then it's not going to have an event, so it's going to add its event next. So, oh, there we go. It did not. Interesting. So the event manager did not go through here. All right, let's take a look at this. Add a breakpoint, and we will remove the breakpoint from the combat system. So yeah, that's the player event executing. And there's no events here. And this never triggered. So let's hit stop and play again. And we're just going to look at this. So I'm moving away, and it's not clearing itself out there. And I can just attack. Basically, after any move or anything, it's not removing this. Interesting. So we're getting the event. We're setting the action, and then it's going to go and tell all those things to do that. So let's see here. Entity. Do you have an AI component? Yes. All right. Let's go look at the health system really quick. This is the last thing I'm going to do just to tighten this up. So if you want to skip ahead, that's okay. But I think usually when I watch, I find it very valuable to watch people debug. So I always think that's useful to kind of see what their methods are. But yeah, I killed him eventually. But that's not explaining why in the event manager this is not being called. So let's say we start. Now I move away, and he's got a movement. Yeah. Well, there we go. So let's see. We have 2 events. Let's resume. Now I move away again. All right, he's following me now. So let's remove this event real quick. Yeah, he's following me around. And now he stopped all of a sudden. And you can see here the what's it called? That this isn't running anymore. So if we stop, let's go to play and start. No, it's following me. Let's select our debug object. Now the enemy dude is following me. And if you want to look, I'll shrink this down in the corner. So we have, he's following after me, he's chasing me. Now he got close enough to attack. And then suddenly he got one attack off, but after he attacks, he just never, he never does anything again. Interesting. So that means it's going to say it does the attack, but the attack does not. Let's see, in our combat component, our combat system may be passing the wrong entity to the entity value here. So if you just hover here over this, it's going to trace back, and this is going to say get entity owner, and that's going to be the thing we are damaging the defender. So the event, this is basically an event in the health system, only acting on the defender, so it's not going to, basically it's not going to say, oh hey, your attacker. So we would kind of need kind of like a combat event that executes and a damage event that does the same thing. So here, let's see, our entity is going to need to be the attacker, because the attacker is the one that is doing. So let's do this. We'll hover here. This is attached. This gets the entity owner of the attacker. So we're going to switch that out to be this guy. There we go. So now the entity owner is the attacker. Oh, was it already? Oh no, yeah, I just undid that move. Now before it was hooked up to the defender. So since the attacker, that should be the entity owner. Now if we go into our health system, which is the one that is executing this, let's see. We have our combat event. We're getting the component of what we're attacking, and this is the event of the attacker. So we're going to need also the event, the entity of the defender. So let's just make that part of the event value. So we go here and we look at our events, and we have a combat event, and we have the attacker, and that's going to be okay. So that's gonna, we can change this to be the defender actually. So in the health system, this is just checking if we're there. So we're gonna get the defender out of here. Oh, we have to use the cast. Let's do that. Defender. There we go. So the defender is the one that's going to get hurt by this. Now in our event where we create this in our combat system, we need to make sure that we do, let's do a file, refresh all nodes here, and we don't have an attacker anymore, and that was basically hooked up to that. So we're going to clear that out, and the defender is going to be this guy, and we're getting the entity owner here, and we're going to pass that in. So the defender should get hurt. So let's say here, we're going to start, this guy has 5 health, so we're going to hit him, we can move away, he's still following us. And he was able to hit me twice before I moved away. Now I hit him again, that's 3, 4, 5, 6. There you go, now he's dead. He can't move around anymore. I killed him. Excellent. Alright, so that's it for this time. Next time we'll set up some more of everything. Oh, we got some errors. There you go, it's pending kill, so it's not going to do that. It's after it died. So let's just do is valid here. And if it's pending kill, it's going to say it's not valid because it knows it's about to be gone. So if it's not valid, we still want to go up here and remove it. So there we go. That works out great, and all of that is good. So don't forget to commit to your repository, commit all your changes. Thanks for watching. Join me next time on how to create a classic roguelike game in Unreal Engine. I'll see you then. Good morning and welcome back to creating a classic roguelike game in Unreal Engine. So let's get right back into it. And one of the things we needed to fix from last time, oh, we have an error in ECS. Let's see if that's the same thing from last time. Some of these spawns, actors are not getting the reference object. So let's just do a refresh all nodes and drop this back in here. We're gonna have to look at that. We probably have some kind of, we might have a circular reference in some of our variable types, and it may not. It may compile down to forward declarations in the actual packaged game, but the Blueprint compiler manager might not be handling it well. But for right now, we're just going to ignore that, and we can do some packaging tests and things like that to see if it works. But the first thing we're going to do is we start here and we take a look, and we can see you jump on each other sometimes if you're one away, because the move event is being sent and it was a valid move, but then you moved into the space they were going to move into, and it's not being checked by the move system. So what we want to do to fix that is in the movement system, go up here, we're going to execute our event, and this is just, let's stop there, the simulation for a moment. So this is all this is doing is moving, let's see, get new location, rounded to nearest 100. There we go. Just mark down what that does. So the first thing we're going to actually want to do, we have our event coming out. We have the entity, and we have our, let's say, does have component, and we're going to look at the position component, and we're going to cast to position component, make this a pure cast. Actually, that's, well, yeah, if it has movement, it's going to have position, so we're not worried about that. That's, if this doesn't work, then you have a problem in how you're constructing your entities. So let's see, we're going to get the position component, and then we want to get the direction of the move, which is this event. We need to cast this to a movement event, so we're going to drag this back in the front, and that's where we cast. So let's just bring a reroute node out here, and this will just help us keep a little things organized while we work out in front of where this is. So this is one of the things we have coming out right here, the entity, what else, going all the way over here to the direction, and that's what we're looking to get right now, and the player, checking if it's a player movement. All right, so we go in here, it does have the component move position component, we get the position from this guy, and then we're going to get the direction, and then we're going to add our int vectors, and then let's get systems, and we're going to get the collision system, which is right here, and cast so we can use its functionality, and contains, collidable, get colliding entities. That's what we're looking for. And there we go, we pass into the location that we're moving to. Again, I'm just going to grab all this stuff, and we're just going to slide it out a little further. And this basically only executes if the move is accepted. So we're going to get colliding entities, or entity in our case. I guess it would be more accurate to say just entity, since we're not going to have multiple colliding entities in the same block. So the collided entity, we can just check if it is valid, and if it's not valid, we can just go over here and do the movement. Excellent, everything works out great. Execute validated movement. So now we know what's happening over there. And this is register component. Can we register component override? I'm just adding in some notations as we move along. I always look for opportunities to just kind of, add some comments, organize things, clean things up, implement new functions that have replaced some old functionality, things like that. But it's building in an iterative manner, so we don't need to go back and change everything every single time that this gets done. So this event tick, we could actually delete these because we don't need them. So we're just going to do that, and that'll still call the parent actor. It's just not being overridden, so we don't need to worry about calling the parent of tick like we are here, or we were before. So There we go. Now, and one of those things, oh, I'll not get into that right at this moment, but we can disable tick on all these actors, which is nice because we have our own event manager running the activity of everything. So we can disable tick, and that basically means none of these things are going to be trying to operate on every frame change, so we don't need to worry about that. And it should save us a little overhead, but they're not running a lot of things anyway, so I know it's just a bit of a slight optimization we'll look at towards the end. All right, now back to this. We did a little reorganizing here, but we want to take a look and say, hey, there's valid, there's something blocking us. All right, now we're going to look what we're going to do here. Let's just move this out, and we're going to get if this is a player move. So if we are a player, branch, and we're going to get the collided entity, and we have a hostile flag in the AI. So if we have does have component, AI component, so here, this is the first thing we're going to check. If it's a player, if that's true, we're going to check if the thing we ran into has an AI component. If it has an AI component, we can, well, I guess we'll convert this to an impure cast to check and make sure it exists, so we don't have to validate it and do the pure cast. So as AI component, get the hostile flag, and then we can branch on this, and if it is hostile and we're the player moving into it, we are going to want to create a combat event. So let's go back and look in our player control system. Now, setting this up might be a nice, this would be something we could create a function in our combat system. So we just call that system and pass the two entities into each other. So look at this. Yes, we have the combat, both have combat components, and we're getting the combat system and passing in an attacker and defender. So what'd be nice is to just pass, instead of passing in these two components, we could just pass in the two entities if we've already validated that they're going to fight each other. So in the combat system, you can click that little magnifying glass there, and we'll just jump in. We're going to create a new function. The new function is create combat event, and we're going to have two inputs, and these are both going to be ECS entities, and we'll call this attacker, and we will call this defender. Now this will only work, of course, if they both have combat components and things, and that's fine. If they don't, it just won't do anything. So basically what we're doing is checking, does have component, casting for both of them, and if they do, we're going to create a combat event with this function we already have. So first we do the attacker, and then we do the defender, and then we can pass in their components, and there we go. So if they both have combat components, so the fact that we are choosing to create a combat event needs to be determined. It needs to be determined outside of this functionality whether or not it is valid. So we're not just going to call this every single time two things run into each other. In the control systems, the movement systems, if they run into each other, they'll determine if it's valid or not. Just like in here in the player control system, if we're getting the colliding entities, did you collide in something? Yes. I collided into something. Does it have a combat component? And this isn't even checking if the AI is hostile. That's something we should do, just like we're doing in the movement system. But that's a bit of an optimization. It's not an optimization, I guess I would say. It basically means if we look at it this way, you cannot accidentally kill a cow. But if you accidentally move to a block where a monster has moved into, you will attack it, but if you accidentally move into a block where a cow has moved into, you will not attack it because the movement system check looks for the hostile flag. But here, if you intentionally move into an object that is in a tile and to attack it, you can still attack it. So it only prevents accidental attacks against non-hostile NPCs. And this is something you can do. If we do an attack here and we're in combat and something hasn't, we can make sure and set the hostile flag, which would be neat. So that's something we can do later. Maybe the cows are just stupid and they just don't care you attack them, or they'll die really easily. But either way, we have our new combat event we can just create here. So in our movement system, we are going to get systems manager, get system. This would be something cool to put in the what's it called? Just kind of nestle this in the system event in the system parent. So there are other ways in code that to do this with kind of templates and things, but in Blueprints it's a little different. So like you can do a does implement interface kind of a thing, but we're just going to be doing this with these casts and checks right now, so that's fine. So create combat event, and we're going to pass in, so it's hostile, yes, we had to get the system, and we need our attacker, which is the entity doing the movement, and that's right here. We have we have this thing, so we can do another reroute node just to keep this clean. We're going to pass this all the way down here, do a reroute node again, and we're going to just mark this as the event. So that's so we know this little blue line that's coming all the way down here, like what is this even? I don't know. And this is the that's the event as well. So, but it's the movement event. It's been cast. So here we just need the entity, and this is going to be the attacker. And the defender is the thing that we moved into that we have checked to determine we're hitting something. And so that comes, yeah, that's the collided entity right there. So we can drag that into the defender. So boom, great. Now we need to go back and do the same thing for our AI. And what we're going to do, so if it's not the player, if it's false, something else is moving, we are going to basically say we're not going to look at we're going to look at and say, instead of does have AI component, we're going to look at this thing at the colliding entity, say does have the player control component, and if it does, then we are hostile. So we want to cast this to player control, cast to player control. So there's that. Now that's the one we ran into. Now we want to get the entity. Oh, this is event. Yep, this is the event. So we again want to get the entity out of this. So let's just drag this over here and get the entity. Oops, let me spell that right. There we go. And has or does have component. And we are going to be looking for an AI component. And this will make sure cows don't bump into and accidentally attack you. And we're going to cast this to the AI component and hostile. If it is hostile, we can do a branch here. And if any of these things fail, we can just ignore it because we just don't want it to happen. So there you go. So let's say an AI bumps into something. If it's the player, we're going to have successful cast here. And then we're going to look at ourselves and say, am I hostile? am I a hostile AI? Could have something else that's just moving. It's not an AI. It's it's a tumbleweed moving across the screen or whatever. So if it is hostile, then if this is true, we want to create a combat event. And here the attacker will again be our entity, so the same guy, and the defender will be the guy we bumped into, which is the colliding entity. So the same thing we did here where we just dragged it all the way out to defender. I'm just going to grab it again, drag it all the way out to the defender, and we want to do this if it is true, and we need to get the combat system as well. So we're going to pull this in here, boom, 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 get our systems, and link into our target, because this is a function in the combat system. So, and we can't, so it's like you see this, I'm just dragging this out because this executes no matter what. But you see this is on a different branch of execution up here. So this this function isn't being called. So if I just tried to get the combat system from here and drag it down, it would accept this connection, but there'd be no information passing into here because this has not executed. So that's why we need to have it down here where it executes and provides the information to this. The blue line is like a temporary variable inside the function. So now this should handle, let's give it a test. We'll open up, hit start, and let's move up here. And now there's one space in between us, so we should move towards each other and attack. And we crashed. So there we go. Infinite loop detected. Let's look at what it says. In ECS entity, asserted during does has component with the following call stack. So this is basically, and we looked at this before, this is basically just what was being called. This is very long. So we go event manager, movement system, event manager, movement system, event manager, movement system, again and again and again. All right, so our movement system, let's look at this real quick. The player control system, event manager, movement system, event manager, movement system. All right. So let's see what problem we're having. We're sitting in here and we're creating a combat event. But our movement event is not being consumed here. Well, it is being consumed, but there's no flags need to go back to let anything know because that's handled in the event manager. So let me take a quick look here and say, let's just add a breakpoint and see see where we get. We're gonna hit play, we'll start, and there we go. See, that was just a normal attack. So let's see if I can get away from him. There we go. Now we should go in here again. So we hit this breakpoint. Let's move forward here. We'll move this breakpoint. So we're creating a combat event. The attacker is the entity from the event, which is, oh, that's not in scope. So that's going to be the player. We're up here, so obviously it's the player, otherwise we would have made it to this branch. So, and it's hostile because that's where we're bumping into an enemy dude. So we're going to create combat event. We're getting does have components from the attacker and defender and passing it into combat. And now we're checking here. And we're saying, get the health systems. This is all working. And we're spawning a combat event that will go to the health system. But we never made it to the health system. We're going back and forth between the ECS does have component and, we're going back and forth between the movement manager and the movement component. So it looks like what was happening was the movement system was creating a combat event which was being passed to the event manager, and that was not okay. All right, this makes sense. So let's go look at the event manager real quick. We'll stop this here. Where's my break point I had in the movement system? Let's remove this breakpoint. We're going to resume. All right. So basically what's happening is the movement, we're in our event manager, right? It's executing this event in our movement system. Now, while we're still in here executing this event, we haven't finished executing, the movement system is coming in and saying, hey, create a combat event. Now, since the combat event time takes less time than the movement event does, it gets inserted ahead of the current movement event. And so since we're getting, the initial one, it's going to remove that. It's not going to execute it. It's going to continue down this path once that event has been inserted into the front. And then it's going to remove that combat event that just got added. And then it's going to go back and try and run the movement event again and again and again. So what we need to do is ensure once an event has been executed, we need to set the current time before we execute our event, and then set the time to be, a large negative number or something. So let's get this. We're going to move this ahead of the execution path. So now we have this. This is how long the current event takes. So we want to execute it no matter what, and we want to keep. Once we execute it, we want to make sure it keeps in the front. So we're going to execute it, and after we execute it, or I guess before we execute it, because we need to do it if something comes in to add it. So we're going to get this event and we're going to set the time, and this is how long it takes, and we're just going to set this to a large negative number, minus 999,999. Sounds good. Let's do 4 nines, some old Final Fantasy there. So there we go. So that should prevent this loop from happening again. So let's just start and check. So we're going to move up, and we can move in. Oh, we did the same thing. Let's see, do we have the same call stack? Event manager, movement system. All right, let me give a pause in the video here, and I'm going to read into this a little bit further just to make sure. Because I don't want to spend too much time just kind of staring at the screen thinking about stuff. But I'll just tell you what I found when I come back. It shouldn't be too long. Well, it'll be instantaneous for you. All right, so that didn't take too long. So basically what was happening were we're adding a movement event, and that's turning into a combat event. Now, the movement event is at the head of the path, and it's only going to get removed down here. But what was happening was when we were adding the combat event, coming in here, adding the event, it was getting put at the end, which was fine, but it was saying, hey, consume the events again, because I just added a new event. So it was coming back here, going through this path, executing the movement event again, because it never got a chance to come out here and remove it. So it's basically going into here, following a certain path where it's calling back to add another event, coming back to the front. Now the only way that could happen, the only time this is called, is if we have a player event, basically. So we need to kind of change how we're counting, we're determining player events exist in the chain. So we need to account for having multiple ones like this when we need to remove them and things like that. So the movement event, we could put a rule in there where we're saying any event execution cannot immediately add another event. We need to have a delay in the processing, but then that would have the events come in the wrong order. So we want to be able to do this, but we need some kind of flag or some kind of system to say, hey, only run this if you have no player events and you're getting one, and only set this to false once there are no player events left in here. So let's just make a variable, and we're going to call this num player events in queue, and this is going to be an integer, and it's going to default to 0. So we have this, and so if we're getting a player event coming in, this has happened. We've gotten a player event. We're going to get this guy, and we are going to increment him. That's adding 1 to him, saying, hey, we have 1 more. Now, we only want to enact this stuff basically on the first event when it goes from 1 to 0. So if we have 0 player events and we are adding 1, then we want to do this. So if this is equal to 1, then we're going to do a branch here. I'm trying to think if there's another way this could occur, like if we're counting down, and if an add event has been called, but if an add event is being called during an event execution, there's no way to remove it before this occurs. So we should be safe with this. But this is something we're going to probably need to look at again in the end. So that looks good. So only time we can tell it to consume the events is there. Now we need to say, we need to decrement this every time we remove a player event. And we don't want to automatically set this to false. We only want to set this to false, when the num player events is equal to 0. So we're going to get this. We're going to decrement the integer. And so if it's a player event that has been executed, we will decrement the integer. And we will get, well, we don't need to drag it in again. And we're just going to say if this is equal to 0, and only then, so the decrement, it says subtract 1 from the best specified value and set it, and that's an integer operation from C++. So basically, you're changing this value in the node, so you don't need to set it here again. So if this is equal to 0, if this is true, then we are going to say, hey, there's no more player events. But if it's false, we're just going to continue on and do stuff. So let's look and see. This should keep us from having an infinite loop in there. So let's open up and we'll move, and there we go. We can hit each other. That was nice. Do it again. I think I killed it. Yep, it's dead. So we can add a cool little death animation. Still hurting it. Die. So you can hack on the corpse all you want, but that's great. All right. So let's close this out. And so we have all this stuff going on, all this information, and we want to see it now. We want to see who's got health, how much health they have left, how much health you have left, all that kind of good stuff. So we're going to go and let's create some UI information about the player. So we could add a UI for like health bars for the enemy and stuff, but I don't think I want to do that. I'm just going to stick to making a player UI, but we'll make notifications for when the enemies get hit and stuff like that. But right now, let's get rid of the win and lose buttons. So we can just delete that and right click and delete that. So what we want to do is add in just a couple of Let's add in a vertical box first, up here. And in this, we're going to add another vertical box. Let's just give this a name, and we're going to call it player stats box. And this box, we're going to call it health. And in here, we want to add a text just to let people know what it is. And we will call this health. Whoops. And underneath it, we want a progress bar that we can set manually, and this will keep that as a variable. Nothing else should be a variable really. So this is going to be health bar. Now this is going to be based off of a max health and a current health. So if we go back to our components and we look at our health component, it has a health in here. So let's create another variable called max health, and let's make that an integer. Let's save that. Now we're going to need to update this in the entity creation system, but first we're going to just create a couple functions in here. It's not really going to be functionality for the game, it's just going to be data setting and getting functions. So what we want to do is we want to have one called init component, and let's delete that real quick, and we're going to go back to our main and our base component. And what we're going to do in here is we're going to create a function called a init component, but we're just going to leave it blank and override it in the other sections. So what we can do is we have init component. So now we'll just go back to our health component, and we want to override the function init component. Now, I'm just trying to think if we just want to make these exposed on spawn when it's created, and then we can pass in the values and things like that. So like right now, if we go and look at the entity manager, we have create the player, and it creates a health component and sets the health. So we could have kind of like an init this component and pass in the values we need. So we wouldn't be able to actually override a base init function because we'd have to change the arguments and things like that. So yeah, let's do that per component. We'll just delete that guy. And then any component that needs an initialization, we can call it if we want to. So let's delete this and create a function called init component. And we have our inputs, and we're going to have max health. Oops. We call it max health, and this is going to be a type integer. And we were going to have this be health of type integer. And basically, this is going to come in, and we are going to set max health. And then if this is equal to 0, we'll do a branch. If it's equal to 0, like basically someone has not set it, and that's true, we're going to set health to max health. So that's just saying you can only set max health and ignore the other thing, and it'll automatically start the thing at max health. But creating an injured character or monster or loading from a save will allow you to set the health. Otherwise, we want to set the health down here of the health that's being passed in. So there we go. Now we want to create a function to set health and to set the max health. So our health component is going to have a function where it says set health, and this is basically going to take in an input where it's a new health, and we will just set it very simply right now. We might use this later. And for helper functions, we could do a couple other ones where we'll make a function that's called like remove health, or we could say, yeah, we'll just call it remove health. And basically what this is going to do is take an input as an integer, and we'll call that damage, and this will go in get health, oops, subtract it. I'm just trying to think if this is actually something that'd probably be better to put in the health component system, where we can just call removes and stuff, and the set values are going to be here. So let's undo that. We're going to just call this set max health. So what we're just going to have setter functions here, and get, we can just get the variable. We don't need to make it hidden. So we're just going to set this, and if we want to change the max health, we can do new max health. So any kind of logic functions we can leave in the system as opposed to doing that in the component, so we can make sure we're separating the logic and the data. So now we just set that up. So our in-game widget is going to be basically, we're going to go in our graph here, and there's the test win and test lose button. Those are no longer in existence. So we want to set our progress bar, the fill color, we'll make that green because it's a health bar, and we can have the default percent to be at 100%. So, and if we want to do, let's look at our style, fill type is left to right, so that's good. When we can, and another thing we can do is, we cannot put the text, but we can have a let's add a canvas panel in here. We'll drag the health bar in it, and let's tell it to fill up there. The size to content we want to be as wide as this is, which is, how wide is this vertical box? There we go. Size X, let's just call it 250. Size 350. So it might get a little bigger or smaller, but we'll leave it there for now. The horizontally aligned fill, and it's the canvas panel. There we go, 250. That'll be the same size. So let's add text in here right below the health bar, so it'll show up on top, and this will be the health text. We're going to make this a variable, and this is just going to be a number representation of how much health you have left, just like that. And we can size to content, and let's size to content as well. No, we don't want to do that because it's not going to have the content, but let's make that actually not size to content, but we're going to call the size Y 40 and the size X to 260, and we'll make this canvas or the health bar 40 also, so it lines up well. And our text, let's anchor it right in the middle here, and our position, well, is not going to be, we can make it alignment 0.5 so that centers up. Well, it should center up, but oh, it's filling the area because of its size. So let's put that back to 0, and we'll put our anchor back to the left here, and our health bar, our position 0, And what we're going to do is the text is going to justify in the center. That's what we want. I was trying to do it with the widget instead of doing it with the functionality in the text. But that looks better. All right. So now we're going to have a function in here which is going to, we're just going to call this a custom event and update health. Now we want to get in a health and the max health. So we're going to have the two inputs here. There's going to be two integers and health and max health. Oops. So anytime either one of these are updated, we just go and pass both of these in. So we'll get the health text and set text, and we want to do an append. We'll do str search to string, and then we can make an append to build our string. Now we want it to be health, and then a space, and then the bar, and then another space, and then our max health to give us a representation of what the health is in text as opposed to just the progress bar. So you have exact numbers. And we also want to set the progress bar, or health bar, get it, and set percent. And that's going to be a float, which is just fine. So we can do health divided by, let's convert these to floats just so we can get our float percent as well. That'll be nice and clean. And divide, float divided by float, and then pass that right in there into the percents. So every time we want to update to this widget the health and max health, we'll call this event. So we need a reference to this widget from the player's health component. Now, since I kind of view, I don't really view this as logic, so I'm not going to put this in the health system. I'm going to keep it in the health component because this is just a representation of the data. It's not a game functionality. So this is just gonna be whenever the data itself updates, using these update functions in the health component, it will update the widget that it has. So let's say the in-game widget reference. This is going to be a reference to that. And what do we call that? In-game widget. Yep. And we'll have an object reference to that. So we can get it, and we can call our custom event called update health. So whenever set max or set health are called, we will pass these in. And we can just wrap this in a function itself. It is call widget update. So in our set health, we can also call widget update. And we can look at it, and right here, it's just going to pass in the values. So whenever they change an update, we'll change an update what happens on there. So let's go back to our health system, which is in systems, health systems. Now we have all these things where we're setting the health. So we can, in here, let's create a new function called damage, and a new function called heal. Oops, not heal. Ooh, getting close. There we go. And these will each take in the health component and the number. So this is going to be a health component reference and an integer number. So component and amount. And the same thing for damage. Two new parameters. And this is going to be the health component in question and the amount. And basically what this is going to do is get health And the heal is going to add the amount because we're healing the character. And then we want to take the component and set health. And that's going to pass in our new health. There we go. Hooray. Now, let's go back to our health component real quick, and we have the init. Now, we're not using the right things here. We want to do the set max health as opposed to just setting it directly. We want to anytime now that we have these set functions, we want to use them anytime, even inside the component. We set max health, and we also want to do the same thing for the set health. So we can just replace these sets because there's extra functionality in here with that, and just delete those two, and there we go. So now our health and our max health will be updated properly, linked to our widget. But first we actually have to tell this where the widget is. So we have, let's go look at our health system here. We're going to finish up, we have the heal, and we can just copy this, and we are going to set up the damage. But instead of a plus, we're going to do a minus. And we'll drag in the amount and pass in the new health component. And we want the target here. And what we can do is, back in our event graph where we have damage, we can do the damage function, which has our health component will pass in, and the damage amount, which we'll pass in right here. And so that sets our health. And here we still want to look at we're still going to want to look at if it's dead or not. We can put this in a function too, but for right now we're just going to leave it. You know, this is just bits of streamlining, optimizing as we go along. So our damage is going in, so we can get rid of this, this, and this. There we go. So, we're damaging the player. We don't have any healing yet, so we're not going to put that in real quick. This is just executing a combat event. Now, let's go back to the entity manager, and we're going to init this component. And for the player, we can just set max health to be 100, and we can leave the other one at 0, and that will, automatically set it to be 100 based on the logic we have in there. So we can do the same thing with the monster, where we do set a max health, and or no, not max health. We want to init, because that will set everything, and that'll set him up to have 50 health. There we go. Now, the health component. So when we create our player, we're going to be moving into the game state, but the game widget is already going to be created in the player controller. So whenever our ECS, the entity manager, we can hook up any number of widgets and things we want to set in here. So our health component in the create player, not the spawn monster, this is going to have some extra things. So we can just do set user, set widget, set in-game ref widget, and we can just use an Unreal Engine function called get player controller, get 0 index because we're single player. We're going to cast it to the roguelike player controller. It's the only one we're doing, so we can do a pure cast, and we can get the in-game widget, or it's called in-game menu, but it's the in-game widget reference. So that'll allow it to do that stuff. Now our health system, or no, our health component, we don't want, these are health components, these are on monsters and stuff like that. So whenever we call widget update, we basically just want to say, is this valid? If it's not valid, we don't care. We just want to ignore this. So we're going to say, is this a null pointer or not? And if it's not, we're not going to do anything. The monsters and stuff will just deal with their own stuff. So let's go here and play. See, we got our health bar there. It looks beautiful. Let's go up and fight this guy. And you can see our progress bar is going down as he hits us. So let's get rid of that collision message there too. And that's in the movement system. And go down to find results and type in print. Oh, it's not in there. Where did I put that in? Oof, all my error messaging. Let's look up the word collide. That might be a bit too vague, but if we can find a collide in the, yes. So we're going to remove this message because that was just for debugging purposes. So now we can hit start and go boom. And there we go. We're fighting. This move is not valid. You will collide. Where else is that in there? There we go. Oh, this is from the old logic. Let's just delete that. There we go. We know our new system is working now, so we don't want to keep around a bunch of old code stuff. But there we go. Boom, 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 boom. Boom, 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 boom. Now he's dead. I still can't walk through him. We can make some kind of death effect, make the monster disappear, but you can see you get hurt. It's all good. Now, let's do a, what's it called? For the health component, we can, let's do this the health system. When someone takes damage, we can get attach parent actor, get location, and what we can do is create a little floating bit of text that shows how much damage occurred. And let's create a little actor for that actually. And we are going to go down to the UI for this and make a new blueprint class, and it's going to be an actor, and it's going to be damage or health text. We'll just call it, actually let's just call it health change text. And this will just make a little floating number. So let's bring this over here. Let's close up some of this other stuff real quick, just to keep our tabs organized. And we're going to add something to this called a text render. Now the text render, you can see it doesn't follow the camera. So let's do this. We can in the construction script, well, let's do it in the begin play actually. We can get camera get player controller. Or we have to get off this execution pin here. Get the player camera manager, and we're going to get for camera 0. And we want to get view or direction. Let's see what we can call. We want the camera manager, and we get camera rotation. There we go. And can we reverse? Let's do this. I know there's a rotator we can do here. Well, let's just multiply it. Scale rotator. I believe that might work. You do, because we want it to be facing the camera. We don't want it to be basically we want it to be facing the camera. We don't want it to be what's it called? Facing away from the camera. So in the begin play, we want to set actor rotation to this, and then we can just have it float up, and we can have an up vector from this, and that's going to give our and this is going to, let's promote this to a variable, and we're going to call it float direction. And it's not going to float up in the world, it's going to float up relevant to the camera view. So we might have to fix this, but we'll just do an event tick and add local offset. And our delta location is going to be float direction times a float times a float. So basically we'll have it move, let's see, 10 Unreal units every second. So we're multiplying by the delta seconds, so in 1 second has passed, it'll move 10 units. Let's make that 50, a little higher. And then we want it to move in the direction of this vector. And there we go. The get up vector always returns a unit vector. So there we go. We don't have to worry about scaling that. So what we're going to do is set the text in the text render in our construction script, and we're going to have a value called text. Let's do that. There we go. Of type text. We can get it, set it in here. So when it builds, it'll pop into existence and set itself up. So we're going to make this instance editable and expose on spawn. So we want to do our health system. Go back here, and we're going to spawn actor from class, and it is going to be a health change text. And there he has our text. And we want to get our actor location. We want to add to this and basically just make it closer to the camera. So we'll go up 400 units, and we can split this and put it at this location. When it spawns, the rotation is going to get changed on begin play. The scale, we can always spawn ignore collisions, although it has no collisions, so it should not matter. So this is damage, and we can, in here in our text render component, we can change the font or the text material and things like that. But here we go, the text render color. That's what we want. So let's add a new variable and we can call it the color. So let's, well, we don't need that out again, but set render color. And that is going to be a color structure. So there we go. And that can be exposed on spawn and instance editable as well. Let's compile. So our health system is going to pass in we'll do a file, refresh all nodes to get that to pop up. So we're going to pass in the amount as our text. So integer to text, it'll do an automatic conversion. And you can set some parameters here, but just leaving it like that should be fine. And since it's damage, let's set up this damage to make it a red color. So we can make a color. Blue, green, red, and alpha will be 1. And there we go. So let's see, oops, what does this need? Error. Convert color structure to linear color structure. That's a color structure, and spawn actor health change test. So let's look here. I guess we want it to be a linear color. Do we? No, that's a color. Why is it being angry at me? It's saying in the health system this color. Let's do a file, refresh all nodes again. Compile. Compile. It still doesn't like it. We can split the pin struct and do this. Let's compile and see what happens. It's still saying failed building connection with convert color structure to linear color structure by reference. Interesting. Make color. Let me see if we can do we'll recombine this, and it's just not, it doesn't like it for some reason. I don't know, that's really odd. I'm not sure about that. That looks like it's something weird going on in the engine. So what we're going to do is, just since we're only going to be looking at red and green, I'll just make this an integer. And we can do a switch on int. We'll get rid of the default pin. And we're going to set if it's a 1, or if it's 2. If it's a 0, we can make that red. So we'll do that. Oops. And if it is a 1, we will make it green. And let me see, what is the text? Oh, these are looking for RGB type values. So let's make this 255 and 255. So 0 is damage and 1 is health. There we go. So we can go back to our health system, and since this is damage, we'll leave it at 0. We can compile. Just do this to make sure, refresh. And let's go see what these look like. So, oh, they're a little bit small, and they were going the wrong way. So they were upside down and going the wrong way. So we can do that. We wanted to move a little bit faster and kind of to disappear pretty fast too. That's not a bad place for it to appear. It's just upside down and move the wrong way. So we'll go back to the health change text and get camera rotation. Actually, we want it to be the camera rotation because, I'm not sure about that actually. Well, let's just try that real quick because of how the text renderer rotation works. Yeah, it's still flipped, and now it's just moving away. So yeah, we want it to move up and not away. So get the forward vector, get the up vector. So you can see it's just kind of floating into the ground as opposed to going. I was thinking about it going, up that way, which would be more interesting. So let's make this go faster. Make it go like 250. And we want the up vector of the camera. So we're going to get, let's just get the pawn, get player pawn of 0. We're going to cast this to the roguelike pawn that we're using. And then we can get the camera. And get the actual thing. And get rotation, get the world rotation. Now let's see what this does for us. If we just pass that in there. Oops. There we go. We can play, we can start. Let's do our damage. Doing the same thing. So this is that's why the movement is. Let's do an add actor world offset as opposed to a local offset because it's moving it in the direction based on its own rotation. That's why it's not moving correctly. So let's do that, and we can actually bring back that other stuff that was working more as expected, but let's try this out real quick. There it goes, moves up and kind of will disappear in a little bit. We can make a material that fades it out and all that kind of stuff. So, but now it's upside down and backwards. So we want to let's see. Face camera, get camera rotation. We have the world rotation, set actor rotation of the camera. And it's backwards still, so we just want to flip that around on rotate on an axis. Combine rotators. Let's see what we have here. Rotate. We don't want to rotate the vector, we want to rotate the rotation. So, but we want to do that in the local space for the vector, for the rotator itself. Get the rotation vector, invert rotator. There we go. That should be what we're looking for. No, it's upside down. Maybe the text render rotation isn't working as I expected because I don't even know where it is. Show yourself. Huh. Oh, maybe because it's this value is being in the constructor. Let's remove the construction script real quick. And oh, there it is. Because it was being set to nothing. So this is okay. This is looking up at you if you're in the forward X direction. So when its rotation is 0, it's facing forward X. So if we want it to be facing the camera, let's see. That would be up. So let's just do a get location. And we'll get a world location here, and let's get a look at. Let's get a direction. Where's my look at? Find look at rotation. There we go. So the start is going to be this guy, and the camera is going to be the end. This is going to be the rotator. I don't know why I'm having so much trouble with this, but that's okay. So let's play, start, see what happens this time. Yay, look. That's neat. It's kind of turning itself to face because it's not directly above you. So we just want to, what we'll do is we're going to set the rotation. So if X is up this way and Y is over this way, we should just be able to lean it back and then do a 180 on the Z axis. So let's add a scene component to put it in the base. And we are going to keep this guy. And since the camera's not spinning around, we don't really have to worry about all this other stuff. World rotation. Oops. Yeah. Get camera. There it is. So, all right, there we go. So now we'll just set this relative rotation, which, so if we lean it back, let's do 90 and 180 and see what this does for us. Yay, look at that. Now we can have the text and justification. The horizontal alignment can be in the center. That should be all good. We can go back and fix our construction script and let's see how this looks. Yay, look, things are getting hurt. Excellent. It looks a little over, but that's just kind of how the it's much higher than the actors themselves. So we'll have the event graph, and on start we'll have a set lifespan of 2 seconds. So we can zoom all the way out here, and boom, you know, they disappear. It goes up a little ways, but that's all right. Let's do 1.5, a little less. Anyway, there we go. So now we can see the monster getting hurt, and we can see our own health going down and stuff. So let's add some other stats here to the in-game, to our systems, and we have our ECS component, and we're going to have our combat component. So our attack and defense. So just like set attack and set defense, we're going to have set functions just like in the health component. We'll call this new defense, and we will set our defense, and we'll have a function called update widget, and this will be a reference to the in-game widget. So we'll make this type in-game widget object reference, and we can get it, and if it's valid, valid, we will do stuff. We need to create a function just like we did for the health information. So our set defense and our set attack, let's add the input to this function, new parameter, it's called new attack. And here in our in-game widget, we can, we just want to call update widget in both of these things. Our set defense. There we go. So we can go back to our, I closed the widget, go down to UI and our in-game menu. And in this vertical box, we can have some more neat stuff. Text there, and we can call this attack power. Oops, I don't want to call that the name. I want to put that in here. Call this attack text. It's not going to change though. And then we can have a text below that. That's going to be the actual attack power. And another text below that. It's going to be called defense. And we're going to just name it or put the word defense in it. And text below that. So we're gonna this is gonna be a variable, and it's gonna be called defense number text. And this will be a variable also, and it will be called attack number text. So we can go down to our graph, and we can do the same thing here, create a custom event and update attack defense. And we will pass in 2 integers, and we'll call it new attack and new defense. And there we go. So let's save, compile it real quick, and we will get our attack defense number here. We get the component, and we set the text. And we're just going to drag in the attack, and there'll be an integer below the description. And we'll do the same thing for our defense text. Oops, we don't want to set the component, we want to set the text of the component. There we go. So we'll drag this over, and boom. Beautiful. So now, the combat component, we can also create an init in here with our new parameters, new defense, or let's call this new defense, because attack becomes first always. There we go, new attack, new defense, and we'll set our attack and set our defense properly. And there we go. So now we can go back to the entity manager, and we can do the same thing here for our, where's our combat component? Down there. And we want to init component, and we'll just use the same values here. Let's do something a little lower. We'll do like 8 and 4 to start out. And then we can set widget. This is setting the reference from things, so we can actually grab the same stuff down here, and we can use all this because none of this needs to be executed. It's the pure cast and it's an engine function and everything. So that should give us our attack and defense. So now this should say 8 and 4 when we start. Oh, so it says text block. So let's see here, init component. Oh, the init component was not calling. Oh, but the set attack and defense should call update widget. So the update widget, we never set that function up in here. So we get, so if it's valid, let's update attack and defense. If it's not valid, we don't care. And pass it in. And so this actually passes it to the widget. And we never have to worry about it again. Nope, still not working. Why doesn't that like me? This monster can beat me up pretty good now. I'm dead. Continue, quit. So, what do we got? I'm looking here for it's updating. We want to set the text defense and attack number. But it's not happening. Where are we going here? So it's not happening. So, because initially, let's see, in the entity manager, we're doing the init component. Oh, we're setting the widget after we init the component. So that won't work because it's not being updated. There we go. Let's do that for this too. Actually, we could make the widget reference part of the init, but no, we'll just leave it for now. Let's stop messing around with stuff. All right, so now this will init after I've set the reference to the widget, so it'll actually have, there you go. So now you can see the monsters beating us up. We're dead. Quit. All right, cool beans. So now we have our health and our attack and our defense power and stuff. So let's create a 3 entities. So we're going to go to our entities and our entity list, and first we need to do a couple things. Let's add a new component. We're going to call it a ECS component, and it's going to be an inventory component. And this is basically something we can pick up. Now the inventory component can have all sorts of stuff going on, but let's go look at it. We'll set up our inventory system, and inventory system. Oops. And that's for the handling of inventory components. And all right, so let's go here, and do we have the level components? Ah, we do. Let's go to the full blueprint editor. This has nothing in it right now. So let's add this to, do we have this on the, we'll go to the entity manager real quick, or actually the entities list, and we can make sure the player has a level component. There we go. So let's add some information to the level component. Variable is going to be level, and it's going to be level 1. Do an integer, we'll start off at level 1. It's great. We have a value, let's say this is how much the player improves each level. It improves their attack, improves their defense, going to be a simple leveling system. Oops. So we have attack, defense, and health per level. Let me just fix the spelling there. So what we can do when we create our player, we can determine and say, let's set up our player's level component, and let's set health per level, and we'll give him 10 extra each time he levels up, and we'll set attack per level and make that 2, and defense per level, not attack, here we go. I want to get it. Set defense per level. And so let's make them every time they level up. I guess we can think what the max level of a normal playthrough would be. We'll try and set the XP values so they get up to level 20 or something. So we'll give them like 1 attack and 1 defense right now, so as they level up. So why is this angry? Oh, we need the entity. All right. So every time they level up, it's going to apply this information to the player. So let's go to our level system, or the level component here, and add a few more things, an XP and XP per level. Now we want them to get have more experience needed per level. You start out with 0, so let's make this an array, and to get to level 2 they need 100. Get to level 3 they need 200, but then to get to level 4 they need 400. To get to level 5, we could just make this instead of make this an array, we'll just do a math equation and double it each time. So the XP per level, we'll compile this and make this 100. So we just want to make it twice, or doubling every time. So if we need XP per level, whenever our XP, let's create a function. Well, we don't want to put the functionality inside the thing, so we'll go up and do our level system here. Level system. So we have our variables, our components. Let's level components reference and do an array. Monsters can level up too, it's okay. And we'll override the register, and we can cast to a level component and just add, there we go. So now what we do when we can consume an event, and the event should be kind of like we'll have it as a 0 time thing when we create a level up event. So let's just do execute event, or we don't really need to add this to the event system because it's something that happens, but let's just call this add XP, and we want to create a custom event and name the event add XP. So we can add an input, and this will be an integer type, and let's call this XP. So, and we will get also an input as which our component we're doing. or we want a level component. There we go. So I'll pass that in when it gets stuff. So get XP. We're going to add to it set XP, this value. Now we're going to get XP per level. And if this is now greater than that, I'm going to branch here. If it's true, we get to do all sorts of neat stuff. We're going to set XP for level to itself times 2. So it's just going to double each time. It starts at 100, goes 200, 400, etc., etc. Now we want to get the entity, get attach actor. Let's do attach. Pattern editor, cast to entity. And we will see if it has a combat component. And if it does, we are going to let's do another thing before we do this. We'll also get a level, and we can increment it by 1. We can just do that there, so you can see what level you are. And we want to add this actually also to let's create a set level function here in our level component. Set level, there we go. And update widget. We're just going to do the same things we did the other place. In-game widget. In-game widget. And we can just add our level to that. So we get this, and if it's valid, we're going to execute, and we're going to send it its level. So whenever we set level, we're going to call this, and this is going to be our new level. New level. We'll just pass that in as integer and set the level internally. And then we update our widget. The widget is our in-game widget here. So let's do custom event. It says update level. Now, since our combat component stuff is going to change, let's just do this real quick. Update level. We're going to have an input of new level, which is an integer. And we can go to our designer over here. We can drag in 2 more text blocks. And we can make this one a variable and call it level text. And this is going to just say the word level. So there we go. We go down here and go level text, get it, set text, and our new level is going to come in. So there we go. And in our entity manager, when we set our level component, we can have an init of the component, and that's just going to call update widget. A set level will too. So if we go back to our entity manager where we create it, we are going to do this is the level component, right? Yeah. Let's do an init component. That's not going to have anything going in right now, but we can set this up level stuff later. So basically, like if we load a save, it starts level 1 and then it'll find out, how much XP you saved, and it says how much health should you have, how much attack, etc., etc. So let's go back here to our level system and our level component. So we're going to update the widget, set level, new level. So our level system is going to come in here and we want to set the level. Oops. And we want to do our current level +1. Let's just drag this down here. And that's the last thing we want to do. So we're going to wait a moment to set this up. So as component, and we're going to set attack and set defense. And we're going to get attack and add 1 to it, or add integer plus integer. So our level component is going to have a value of, let's just grab this right here. It's going to have a value of attack per level, and we will add that into our attack. And the same thing for defense per level. Oops, we don't want to set that. We want to defense per level. Get defense per level. So we're going to add that in here, and this is going to get the defense that we currently have. Add in our defense per level. Boom, all set. And then we update our level, and that'll update everything else that needs to be done. There we go. Excellent. So what we need now is a way to give experience to the player. Oh, and so this is another thing we need to do, and basically it's going to say we can make this a while loop, and we have XP per level, and that's going to iterate up. So we get our XP. We're adding in our XP, and then we're comparing it. So we'll do a while loop, and it's going to branch basically on this and say, so if let's say we need to get what's it called? If we get 1,000 experience, and they'll send us up 2 levels, and that's fine. So we'll just loop through, and we'll do this again and again until we've consumed as much experience as we can. So and our level component, I guess our level component could have something how much XP is it's worth also, XP value, and we can give this to monsters and stuff. So let's make this an integer. An XP value, the default's going to be 0. But in our entity manager, when we spawn our basic monster, let's go to our entities list, and let's give our monster a level component. And there we go. So in our entity manager, we can do this. So it does have component and a level component. We don't need to really worry about setting up all this other stuff. Where it says set XP value. We don't really have to worry about setting up all this other stuff, because right now we're only going to set give XP to the player. So we'll give him 500 XP value for this little starting monster, which should be really neat. So now let's just play to make sure we got stuff working. Our level's not setting, so let's go and look at the player. We are in the component. We need to actually pass in the widget input init component update widget. So where are we? ECS manager. So we're going to do in the level component, we want to pass in input in game widget. We'll also do our level too. And a new parameter. Or let's pass in experience, and then the level will be calculated. There we go. Set to in-game widget, and then update the widget. And this is calling set level. So we can have a thing in here where we get XP, or we set our XP basically when we start, and that can let's see, in the level system we'll have to call the level system and add XP basically, as opposed to setting XP in here. We'll add it through in the level system. So let's do, we'll just leave that alone for right now. That's a save load thing. We got a lot of save load things that we need to do. So let's see, we start, nope, still not doing it. So our level component is getting the widget, update level should pass in the level, it's defaulting to 1. Our player in the entity manager is starting out with 0 XP, the default level of 1. Oh, we need to actually pass the value of the widget just like we're doing to these other ones. Oh, we didn't. We were just setting. I like that better. We're setting in-game widget directly as opposed to passing it to the init function. So let's remove that. And then we can update. Excellent. ECS entity manager. So we can just break this connection, and that should be working right now. So now we can see we're level 1. We can fight. This thing's actually going to kill us. So we need to make ourselves a little bit stronger. Let's make the monster just a little bit, you know, weaker. 5 and 2 or something. So we're still not going to get any experience, but we can see we've killed this guy. And so we're going to go in the health system and the event graph. When we execute event, basically we need to find when something dies, the health system needs to know what killed it, and then it can, you know, try to give XP back to it. So the health event, what do we have in there? We have a combat event and a movement event. The health system is event object reference. It's just a basic event. Huh. Did I edit the event for it to be a health system? No. Health system casts to combat. Oh, the health system is executing the combat events. So that should actually be called a health event then. It's going to be that damage and defender. And so let's make a new variable called attacker. And we can make this an entity object reference. So let's go back and rename this a health event because it's being executed by the health system. Much nicer. Now our health system, we have an attacker and a defender. So if your health is less than 0, you know, you have a player controller or an AI or whatever, you're going to die. But before we do that, that's basically killing the stuff. So, but before we can do that, we can go in, we can get defender. Oh, let's cast this to a, oh yeah, we need to do so the defender and our attacker. So if our defender does have component, a level component, that means he has some XP to give. So if this is true, we're going to give them XP, get XP value, and if our attacker does have a component, the level component, we are going to cast and then say and we want to give them XP. So that's what's going to happen is the level system is going to give XP to the component, add XP. So our health system is going to get system manager, get level, or get manager, nope, systems manager, get manager, get system, that's what we want, not the managers. So this is going to look for the level system. We can cast to the level system. Let's give ourselves a little more room in here. We're just kind of jamming everything in. Drag that all out. So if both of these have level components, basically we can do a sequence here also, just to make this a little cleaner so we don't have to catch on the ends of all these casts and everything. So if these both have level components, what we're going to do is add XP. And we want to add XP to the attacker. So we're going to send this guy's component an XP value for the thing we've killed. That should, let's see if we go up 2 levels. It's dead and nothing happened. All right. Oh, errors, excellent. It does have component. Oh, we never set the attacker in the health system event. So we're creating a health event in the combat system. Let's go back to our systems, spawn actor health event, and our health event, the attacker needs to be exposed on spawn. So we go here, file, refresh all nodes, and the attacker is not the defender, so the defender is right there. And this is going to be our attacker. Combat component object reference. We're getting the entity owner for that. There we go. So, alright, let's see what we do now. If we've forgotten anything else. Oh, look, we went up to level 5. Oh, I'm just killing this thing over and over again and leveling up more and more. So there we go. So that's why we need to have a dead and is dead flag. Let's go to our health component, create a variable, and B is dead. So basically it can't be killed again. We'll make that default, leave that as false. Our health system, we're going to do execute event and damage, and basically we're not going to apply damage if something is dead. So or health, no reviving. So let's get from the health event. The event has the component. Health component is dead. So we can just do a branch off of it here. And if it's true, we're not going to do anything. If it's false, we can go ahead and apply damage and do all that fancy stuff. So now let's say we should only get experience once. So Go up here, and we're gonna kill it. We go up to level 4. Look, our attack and defense and everything went up. Oh, we're still leveling up. We'll hack it on this guy. Oh, we didn't set is dead. So basically we're gonna do set dead. Oh yeah, if your health is less than 0. Hooray, you have died. It is now true. There's no way to return. Boom, 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 boom. Yay, I leveled up. Now it's not taking any more damage. I'm not getting any extra experience. We have our neat little player's HUD. So we're going to stop right now. This is a pretty long session again, but it was good move forward. The next time what we're going to do is make a couple pickups. We're going to make like a sword, a shield, and some health items so the player can heal themselves. And we'll make a little inventory. And depending on how long that takes us, we'll try and make our end goal as well. And then hopefully the video after that is where we're going to do our optimizations and finish stuff up. So that's it for now. I hope you enjoyed, and I hope you join me next time in how to create a classic roguelike in Unreal Engine. Have a great day.